Om Namah Shivaya. A very good afternoon to one and all present here. I am Dr. P. Kannan, Head of the Department of Electronics and Communication Engineering, Sri Satyam College of Engineering and Technology. It gives me immense pleasure to welcome you all to Day 6, the final day of the AICTE sponsored ATAL online 6-day faculty development program on semiconductor for smart systems, applications in IoT, AI and next generation device, organized by the Department of ECE in association with IQAC and IIC Sri Satyam College of Engineering and Technology. Over the past 5 days, we have joined through the fascinating the realms of semiconductor fundamentals, device innovation, fabrication processes, AI-driven architecture, and emerging technologies shaping the future of intelligent systems. Today, the session marks the grand finale, focusing on applications such as cybersecurity and innovations in the semiconductor ecosystem. Let us commence with technical session 11. To introduce our distinguished expert for technical session 11, may I now invite Dr. S. Mahendran sir, HOD of Electrical and Electronics Engineering, to do the honors.
A very good afternoon to one and all gathered here. It gives me immense pleasure to introduce our distinguished expert for technical session 11, Engineer Gopi Gavaskar Pandian, Head of Engineering, AARK Global Incorporated, New Delhi, India. Sir brings with him an impressive 30 years of industrial experience in the domains of information technology and semiconductor engineering. He holds a B.Tech in chemical engineering and an M.Tech in biotechnology from the prestigious AICTE Anna University, Chennai campus. Before his current role, he served for 24 years at HCL Technology, where he handled key responsibilities in the semiconductor domain, collaborating with leading global clients across the OEM, FAB, and OSAT sectors. Presently, he leads AARK Global Incorporated, driving initiatives that strengthen India's semiconductor ecosystem by focusing on smart manufacturing, cybersecurity, industrial automation security, and Industry 4.0 compliance through SEMI standards and best practices. He is also an active promoter of semiconductor awareness across academic institutions, motivating students and professionals to pursue emerging opportunities in this vital technology sector. We are privileged to have such a seasoned expert with us today to share his insights on cyber security of semiconductor fab equipment, SEMI standards and practices, a topic of greater significance in ensuring the reliability, safety and resilience of next generation semiconductor manufacturing systems. Sir, we are truly honored by your presence. We extend a warm welcome to you and look forward to your enlightening sessions. Thank you for the opportunity given to me. Thank you, one and all.
So thank you, sir, for the warm and detailed introduction. With great pleasure, we welcome Engineer Gopi Gavaskar, sir, to deliver his expert lecture, sir. The session is yours. Please, sir.
Thank you, sir. Thank you. So, shall I share my screen?
Yes, sir. Wait a minute. Okay. Now you can share your slides, sir, please.
Okay. Good afternoon, everyone. First of all, thank you to Sri Satyam College of Engineering Technology for welcoming to this online faculty program development. Thank you, Dr. Sujata, Principal, and thank you, Dr. Kannan, and thank you, Dr. Mahendran, for giving a warm welcome. So with this, I'll get into this topic of today. So today I am going to have two different sessions. The first session is going to be on the semiconductor, basic semiconductor industrial overview, and semiconductor manufacturing, So I will talk a little bit on that. Then I will see the how say cyber security is coming into picture in the semiconductor manufacturing. In the second session, how the cyber security practices are done in the semiconductor smart manufacturing industry, and then what are the top trends that are currently going on in the cyber security, I will present. Okay, so as Dr. Mahendran told, I'm working in the semiconductor industry for last 30 years, and most of my passion is in the semiconductor. So whatever I learned in the last 30 years in the semiconductor industry, so I will give from the industrial perspective. So I will give what are the data points I will. Okay, and if you have any questions, anything, please stop me and then ask. Any questions on semiconductor, you can ask me. So let us start with the basics actually. So we all know, you all are professors working in the electronics and communication. So you might be knowing all these things, but to refresh our basics, semiconductors are a special type of material which is lies between a conductor and insulator. These semiconductor materials will be able to control the flow of electrons. By doing so, lot of innovations have come in the semiconductor industry. So there are two types of semiconductor, intrinsic and eccentric. So intrinsic, it's when we don't do any doping, we don't do any impurities, but just by heating or applying pressure, we make the semiconductor to conduct electricity. But intrinsic semiconductors are not used in the industry. Whereas eccentric semiconductor, where we do the doping by putting impurities into the semiconductor, into the silicon, and then we'll make it to conduct electricity and control the flow of electricity. So eccentric semiconductors are extensively used in the industry to make all kind of semiconductor material, all kind of electronic devices. So there are two types of eccentric semiconductor, P-type, N-type. So I don't need to explain about this energy band and all these things. These N-type and P-type semiconductor, how it is getting manufactured. To manufacture this, how the industrial ecosystem is what we are going to talk about this today now. Okay, these N-type and P-type semiconductors will be made into two different types of semiconductors. One is digital and the analog. So you all will be knowing the difference between the digital and analog. So digital semiconductors are in binary, it's zeros and one, it will be there. Okay, it is denoted by the sine waves, but denoted by the square waves. But whereas analog devices are the sine waves, and then it is a continuous signal which represents a physical measurements. So if you want to do with physical measurements, for example, you create a sensor in a particular electric vehicles or in a reactors or any industrial walls we want to open through signals, then analog semiconductors are used. Anything to do with physical. So if you want to open a door automatically, if you want to close the valve automatically, if you want to measure the temperature, measure the pressure, sensors, everything with respect to physical, analog is very much used. But digital is completely digital, one set zeros and one. For all your CPUs, RAMs, processors, your mobile phone things, everything is a purely digital actually. Okay, so both digital and analog semiconductors are manufactured very heavily. Both are eccentric semiconductors. I said all eccentric semiconductor actually. So all these digitals and analog finally convert into mobile phones, monitors, digital watches, remotes, all these kind of electronic devices which have both digital and then analog semiconductors, nothing but the eccentric semiconductors actually. So now how these semiconductors are manufactured? So the raw material for semiconductor manufacturing is sand, silicon. It's very cheap, it's abundantly available in the earth. So all the beach sand they take and then they remove the silicon, and that silicon is converted into a wafer, something called as a wafer. This is the wafer round in shape. This wafer is what the precursor for manufacturing your semiconductor materials. Okay, so typically any manufacturing industry, the raw material will be the very costliest one. The raw material cost determines the cost of the product. But in a semiconductor, it is different. The raw material is very, very cheap. We are getting the sand. But the making of semiconductor is very, very costly. The amount of money that's spent, the amount of equipments we need, amount of space, amount of chemicals, all these things, it's highly, very, very expensive to manufacture a semiconductor device. We'll see why it is very expensive. I'll give details about this. So one is sand. From sand, we'll get to the wafer. And second one, from the wafer, we will get into the chip. There are two ways. One is the front-end manufacturing, where the very complex equipments, complex manufacturing environment will be set up, where the chips are designed. Actually, the designed chips are imprinted on top of the silicon wafers. Okay, once the silicon wafers are printed with the dies, then these wafers are cut into small pieces, and then the chip will be packaged and then electrically tested. Then the chips will be made. So after packaging, these packages will be put in an assembly, then become a electronic goods. So before manufacturing, so we also do a design that we normally call as a VLSI design. So the design will give a reticle. They call it as a reticle. This design only will be printed on this wafer, silicon wafers that will be printed. So we have a wafer manufacturing, and then design services, and then front-end manufacturing, back-end manufacturing, and then assembly. All these combined together, finally we get the electronics good product. Maybe a mobile phone or smart TVs or refrigerators, washing machines, electrical vehicles, everything comes from this manufacturing side. So this is a little bit, give. So you have a product design, the VLSI design, we call it as a design house or fabless companies. There are huge number of design house and fabless companies are there. Their job is simply design a electronic circuit. So once they design electronic circuit, then it will be given to the front end fabrication services, where they manufacture the entire chip. Then once the front end is done, the wafer is shipped to the assembly and testing, where they cut the assemblies, cut the wafer into small chips and then packaged. And once it is done, then it goes to the board assembly, the PCB design and the PCB manufacturing. The boards will be assembled. Once the boards are ready, then the boards will be used inside our electronic devices like the mobile phone. So if you have a mobile phone, the mobile phone will be having a board assembly. So that board assembly is consists of lot of these electronic chips, which is nothing but a transistor, small transistors. The billions of transistors will be embedded onto this silicon devices. Okay, so to give an industrial perspective, so design house or fabless. If you say something is a design house, fabless means they are product design, chip design companies, circuit design companies. Their job is simply design the circuit. That's all. Nothing else they do. Second, they call it as a foundry. Foundry means they just manufacture the chip. That's all. They don't do the design. They don't do the testing. They don't do anything. Just if you give a design, they'll just manufacture and then give it to you. That is called as the foundry. Then we have a OSAT. OSAT is a testing, semiconductor assembly and testing, outsourced semiconductor assembly and testing services. Once the chips are manufactured in the form of wafer, they'll cut those wafers, make it a chip, they'll test it, package it, and then they'll give it to board assembly. And board assembly is nothing but the PCB design and then manufacturing. They put it in a board. That board will be used in the electronic device. So these are different things. Design house, fabless, foundry, fab, OSAT, IDM. These are all the companies across the globe that does the semiconductor manufacturing. IDM is integrated device manufacturer, that is comprised from everything they do. For example, product design to board assembly till the product, everything they do is that is called as a IDM. Very good example of IDM is a Sony. We all know the company called Sony, which has, you have a Sony television, Sony phones were there, a lot of Sony products are there. They have a fab also, they have a design house also, they have a testing house also, everything they have. So if you have everything is together, then it is called as a IDM, integrated device manufacturer. Can you give an example, another example of IDM? Do you know any other IDM you can think of? One I told is Sony. Anything else you can think of, comes to your mind? Another mobile phone company, Samsung. Samsung is one more company which does the end-to-end from the product design to the end of mobile phone or a television set, smart TVs, everything they manufacture. So that is also called as a IDM. So I'll give you a list of companies, top 10 companies which they do this manufacturing. So basically a fab, this is a fab overview. So we need equipments, lot of equipments are required. So these are very, very costly. In a fab, 85%, 80 to 85% of the cost will go in buying the equipments. So then you can think of the equipments are very, very complex and very, very big equipments. These equipments are needed to manufacture the chips. So remaining 15% is only the wafer and chemicals, gases, everything. But the 85% of the cost is go to the purchasing the semiconductor equipments which are used for the semiconductor fab. So typically a fab look like this, very big, it is very, very, very huge in nature actually. So it is not very easy to enter this because it is completely in a clean room. Okay, completely in the clean room. So what I mean by clean room is you have hospitals where you have operation status which are very clean because they don't want to get any infections to the patients from the bacteria and viruses. These semiconductor fabs are much more cleaner than our operation theaters, because even a minute particle, if you go and sit on the semiconductor manufacturing, it will spoil the entire yield actually. So it's very, very important to have a very clean environment, much more cleaner than a thing. So you can know the transistor size, right? Now the transistor size are in the nanometers actually. Okay, such a small nanometer devices they are manufactured. The human hair, you have the hair in the human hair, which is about 80,000 nanometers. Think about a human hair, which is 80,000 nanometer thickness. But your semiconductor transistors are manufactured in sub 10 nanometers now. 20 to 40 is the nanometers is what they are manufacturing, but now they are talking about sub 10, less than 10 nanometer size. Think of a human hair is about 80,000 nanometers, and then your semiconductor transistors are sub 10 nanometer. So how small it is? It is much smaller than a virus, a bacteria. So that means the clean room, the room that it is maintained for manufacturing a chip is tremendously neat. You cannot just like that go in, come out. You have to do lot of purification, and then you have to put lot of dresses. Then only we can enter this. So such a clean environment they maintain in the semiconductor fab. That is why the manufacturing of semiconductor materials is very, very complex and very, very clean in nature, very costly also. So this is the another way of representing. So a silicon wafer will be manufactured, then IC design will be manufactured in the term of mask shop. Usually we call it the reticle. Then the silicon wafer undergo many process of oxidation, photoresist coat, photolithography, etching, film deposition. This will continuously be done, and between each and every process there will be inspection, metrology, review, everything will be done. Okay, we inspect whether the process is going fine or not, because the yield of the manufacturing is very important, and they normally look for more than 90% yield. If they are anything less than 90%, the cost of the chip will increase. So they'll be very, very careful in the manufacturing of the chip for any defects. So they said they continuously they do the inspection. They also do a lot of measurements, and then review also will do within every process. Then once content is done, then it goes to low level where the wafer level testing, dicing means cutting it, and then chip level testing, packaging, and then assembly level testing. Once assembled, then it goes. So it's a manufacturing process. So you see that across globe there are around 1,400 fabs are there. No, maybe the count would have been increased to 1,450 or 500. Totally across globe, only 1,400 fabs are there. That is processing 30 million wafers per month. So these 30 million wafers per month is what is supplying to the entire demand of the globe. Think about it. These 30 million wafers we are processing per month, it's what giving the supply to the entire global semiconductor demand. Okay. So there are three different types of wafers right now: 150 mm wafers, 200 mm wafer, 300 mm wafers. This is the diameter of the wafer. Okay. So in the olden days, there were 100 millimeters and all used to be there. But right now, at least in the minimum is 150 mm wafers are there, and 200 mm wafers are there, and 300 mm wafers are there. So if 300 wafers is bigger size, the more number of chips can be manufactured. But 150 mm is very small, very less number of transistors, very less number of chips only can be manufactured. Okay. If you see that there are 18 new fabs are expected this year. So it is keep on increasing. So many new fabs are getting constructed because the demand for semiconductor is going very, very high, and the demand for the people to work on the semiconductor industry is also, the demand is very high. And where exactly it is there? Most of the fabs are in the three regions. One is in America, second is in the Europe, third one is the APAC region. APAC region means China, Japan, Singapore, Malaysia, Korea, Taiwan. So these are the places semiconductor industries are there. No other in Africa, Australia, New Zealand, Middle East, we don't have any semiconductor. So most of the semiconductor industries are US, Europe, and then APAC region. So these are the top 10 fabs with respect to 300 mm wafers. You can see Samsung is the top with the 300 mm wafers. Around 21% of the wafer semiconductors are manufactured from the Samsung. Samsung is in the South Korea. The South Korea's budget itself depends upon the Samsung. See, in Indian government, we do the Indian railway budget, right? Like that, they do a separate budget for the Samsung, the the South Korean government. Such a huge industry is Samsung in the South Korea. And we have a Taiwan, TSMC. TSMC is the world's largest producer of the semiconductor chips. That is also accounting for 15%. And then Micron, Hynix, this is Western Digital, Intel, Global Foundries, UMC, Powerchip, and Texas Instruments. These are the top 10 industries that produces, manufactures the semiconductor chip. This is 300 wafers. With respect to 200 wafers, again TSMC, ST Micro, UMC. UMC is in from Singapore. We have in UMC, Infineon, Texas Instruments, Onsemi, Toshiba. These are 200 wafers, and then 150 mm wafers also is there. But putting it together, TSMC is having in 200 mm, 150 mm, and 300 mm is the highest manufacturer of the semiconductor chip. And then design companies, if you see, I told about the design house and then OSAT. So design house, if you see NVIDIA, Qualcomm, Broadcom, AMD. So these are the top 10 companies. They do the designs. They do only design. They don't do any manufacturing. So if suppose iPhone wants to have a new phone, new brand of phone they want to do a design. So they will go to these companies to do a design. So they will do a design and then give to them. Once take the design, the foundries will do the manufacturing. And then OSAT. OSAT is the next set of after front-end manufacturing. The OSAT is where all the chips are tested and then packaged. So this is the top 10 OSAT company. AAC, which is in the Taiwan. This is the top revenue making company with respect to the OSAT. So which is driving the semiconductor industry is these are the following things: networking and communication. All your networking, communication, chat, All these things is what 29% of demand. It is because of the networking communication, and then data processing. This is the cloud, AI, and all. It is creating a lot of demand for the chips, memory, and then consumer electronics. This is the mobile phones, laptops, everything, and then industry applications. Lot of manufacturing industry, they need a walls, everything that is constituting, and then automated. This is mainly the electrical vehicles where you have a sensor. Okay, in the 2000, if you buy a car, the car might be having 1 or 2 sensors, maximum 10 sensors will be having. But now, if you buy a car, there will be huge thousands of semiconductor materials, digitals are there in the electrical vehicle, especially in the electrical vehicles. It will be AI vehicles and all that. You need a huge demand for the semiconductor materials. The automotive itself, it's creating a huge demand for the semiconductor. And then government sectors, mainly for the space, and then armies, military purposes, there are a lot of spend on the semiconductor. So the semiconductor market is growing, and 2033 it become a 1,200 billion market actually. That means the job market is going to boom like anything for the semiconductor, especially for the electronics, communication, electrical and electronics people. We have a huge number of opportunities. The way in which computer science, the dot-com burst happened in 2000, there is going to be a huge burst for the electronics and communication engineers and electrical electronics engineers. Okay, so do we have a fab in India? We talked about global thing, everything. So do we have any fab in India? Do you think we have any fabs? Do you have any semiconductor industry in India? Anybody? So we do send Mangalyaan, we do send Chandrayaan, we do send a lot of satellites. ISRO we have. How they are sending without semiconductor chips? If India is not having a fab, how they are sending those rockets and the space missions and all India is creating? We have a lot of military equipments that we are manufacturing. Without semiconductor chips, how they manufacture? The answer is India doesn't have a fab. No companies are having a fab in India. But our Indian government has put up a small fab called as a semiconductor laboratories in Chandigarh. So that is started by our Honorable Prime Minister Indira Gandhi at the year of 1981. They started the fab just for the two purposes. One is for the ISRO, our Indian space mission, and then second is for the military purposes. That semiconductor laboratories in Chandigarh is still functioning. So they are manufacturing the chips just for the need of the Indian government for the space and then military. But the challenge is it is put on 1981. They are prepared, they are manufacturing around 168 nanometer transistors, chips. But currently our size is become 10, the sub 10. So there's a lot of competition. We are not able to compete with the other, global players. So that is why Indian government, they taken an Indian semiconductor mission and they talked to many companies across the globe to invest and then create a manufacturing setup in India. The first company, Tata Electronics, they are setting up a fab in Gujarat. You can see here, TEPL. The first semiconductor manufacturing fab in India is going to set up in Gujarat. Of course, SCL is the first one, but it is in a small scale. It's a semiconductor laboratory. They call it as a lab, not as a big industry. Okay, small lab. That lab itself very big. That's a different issue because semiconductor needs a very huge space. So they do specifically special kind of devices. Whatever the space programs we had, the Chandrayaan, the Mangalyaan, or whatever the satellites we are making, all of them, the chips are made at the semiconductor labs. Because we cannot buy semiconductor chips from outside market if it is for a government, a military program or space program, because that country will not provide the chips. So it has to be manufactured indigenously, which Indian government is doing. But now they want to expand it, so that's why they're investing a lot of people to come and then do the fab in India. There are around 10 different companies are shown interest, and then government already approved some of them to put up a semiconductor factory in India. There are around 10 to 10 semiconductor fabs are coming. So what does that means you will have a huge number of job opportunities for the semiconductor and then the electronics and electrical peoples. So I'll pause for a while. If you have any questions, please ask on the semiconductor. And before I am proceeding to the cyber security of the semiconductor thing, if you have any questions, please let me know. Okay, if there are no questions, let me proceed. So as you told, you talked about the semiconductor industry. Semiconductor industry is little different, which does not follow any standards. Actually, it's very difficult because this industry is not a very regular industry. Whereas if you see the auto industry, these industry standards are there, and then formally tracked and audited. A lot of industry collaborations are there. It's a completely a regular sector actually. But semiconductor, you see, it is very, very inconsistent, incomplete because it is physically isolated. The manufacturing environment of a fab is completely physically isolated. Nobody can enter the fab. Unlike an auto industry, but anybody can go and come and all these things. But in semiconductor, is completely. Because of that nature, the cyber security or security aspects of the industry is completely neglected. But in the recent days, the semiconductor industry, because of the industry 4.0, you see the industry 1.0, it's a steam engines, and then 2.0 by electricity, and then 3.0 is where the first electronics and automation came, and then 4.0 it become very, very robust. We talked about advanced robotics, 3D printing, Internet of Things, artificial intelligence, big data, cloud. Lot of things come into industry 4.0. So till this industry 3.0, semiconductor industry never part of this industry 1.0, 2.0, 3.0. It has a altogether separate route. But now it is merging to industry 4.0 because of the IoT and then big data, cloud, all these things joined together. Now semiconductor manufacturing is also becoming a part of smart manufacturing industry 4.0. And that too, after the COVID, many people started working from home, started supporting manufacturing from the sitting at home. They enabled a lot of cloud, lot of work from home, artificial intelligence, everything. That created a problem for for the semiconductor industry also because of the cyber security threat. Okay, so two big companies. One is the Applied Materials. It is a publicly available article. These are all. So they had a very big cyber security attack, and then Taiwan Semiconductor Committee (TSMC) also had a big attack. So around 250 million and then 70 millions of productivity is lost. Okay, so now recently in semiconductor industry also they started worrying about the cyber security, and then they started putting some of the standards and some of the practices that they are following. I will talk about this. See, if you see the cyber security attacks, we are all thinking about attacking the banking, personal applications, and email threat in the industry. All these things we talk about, but the majority of the cyber security attacks happens only on the manufacturing. Why it is happening in the manufacturing industry is because even a small attack they happen that will incur a very huge loss for the manufacturing industry, and they can demand a huge money if they are able to attack the manufacturing. If they are able to stop a manufacturing, they can demand a huge money. Once they get the money, that money is a very huge. So that's why the attack on manufacturing industry is very, 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 very huge. Okay. Then comes the automotive. To automotive, you can say now the AI driven vehicles, you don't need to drive. If you go and sit it, the vehicle will drive automatically you for a home. Somebody can hack you and then they take your vehicle to wherever they want. Like hijacking a flight, now you can hijack an automotive vehicle. If your car also they can hijack. So that means for electrical vehicles, for automotive vehicles, the 30 to 40% of the amount they are spending on securing the vehicle. Running the vehicle is already done, but running the vehicle is somebody able to direct to somewhere place. It's very dangerous. So 30 to 40% of amount they are spending to securing the vehicle from the cyber security attacks. And also, as I told, ransomware. 68% of the attacks happens only through ransomware, and then the network breach. Next is the network breach. So I talked about this. So these are all the industry 4.0, big data, data analytics, industrial internet of things, 3D printing, robots, everything, and cyber security also plays a significant role in the industry 4.0 manufacturing. Almost 30% of the cyber securities are put into the industry 4.0. So industrial cybersecurity is little different from the IT cybersecurity. We call it as a OT. IT is information technology, OT is operational technology. So IT talks about the confidentiality, data integrity, Windows, computers, servers, air condition, all these things they talk about. But in the OT means it's more about the availability, because when the manufacturing is going on very fast, they cannot stop the manufacturing. Without stopping, we cannot give importance to the cyber security. So there are a lot of industrial challenges will be there in the OT sector, which is very vulnerable for the attack actually. So it is a cyber security in smart manufacturing is entirely different from the normal cyber security that deal with their offices or the colleges or everywhere, universities or government offices. Personal cyber security is entirely different from the OT, because that deals with the different priorities actually. So here number one priority is confidentiality, but here it is availability. Availability means your equipment, your manufacturing should be available 24 hours for the manufacturing. That makes a lot of difference. And here they talk with the internet, cloud, network, program, device, but here they talk about the machineries, monitoring, embedded computers, SCADA software, PLCs, HMIs, which is entirely different from information. So between IT, OT, so this is some of the components. So in a systems, when you have a go to a computer office, normal offices or in a colleges, universities, government offices, if you have, all the systems are homogeneous in system. All of them will be having a laptop, all of them having a computers or mobile phones, which is all similar. But if you go to a manufacturing system, it will be very heterogeneous, because this will be more than 50 years old equipments will be there. There are a lot of equipments that are running in Windows NT. Why? There are a lot of DOS operated equipments are running. So how will you give a cyber security productivity for a Windows XP, Windows NT, and DOS operated computers? So that's the challenge. But in IT systems, normal offices, we will be having a 5 years old laptop, non beyond that actually. So it's very easy to update, keep updating, and then secure it. But industrial thing, very difficult. You see the order of priorities. Here safety comes first, then availability comes next, then integrity, then confidentiality. Confidentiality comes, the priority is last. But whereas in the normal office environment, confidentiality, integrity, availability. Confidentiality comes as a high priority. But here safety, availability, integrity is the high priority. So it's a completely reverse. So that makes very tough. And awareness also, it's very inadequate. But here it's good, because we do a lot of training program, lot of awareness is there. But the manufacturing system, it is not there. If you see that, no, this is very come. Also the impact, if any impact happens on the manufacturing environment, it's a very huge. It will be in terms of monetary, death, injuries, damage to physical devices, all these things will be there. But in normal environment, it's easily recoverable. Maybe some monetary loss will be there, but easily recoverable. But here losses will be very high. So that makes manufacturing environment cybersecurity is very critical. Okay, this is just a So we have to combine both IT and OT together, and then we should make the security, cyber security system for the manufacturer. So this is three different types of security will be there. One is the at top level, the smart manufacturing, entire manufacturing facility should be there. And inside that, we have lot of equipment, SCADA systems, PLCs, all these things will be there. So we will be having a separate equipment security, product security will be there. Then the last, the software applications, which are running on this industry will be having the uh, security of the application. So three different securities will be there. Okay, so this, okay, I'll skip this. Okay, now let me take into the application security first. See, if you have application security, okay, sorry, slide is little misplaced. So when we do application security, this is very normal. From the requirements to the end of life, every phase will have a cyber security requirement. Cyber security practices will be there. So we do the security requirements. We'll collecting requirements. We'll do threat modeling. We'll do the design. We'll do the coding. We will do the 4 different types of testing: penetration testing, SAST, DAST, IST, and then we do the penetration testing, and then we do the risk assessment and OS scanning. We'll do, and then end of life we'll do the analysis and then results. So during the design phase, we do the threat modeling. There are different types of threat modeling. I will not go into the details of every steps. So we do follow the STRIDE, VAST, attack tree, CVSS, FASTA. These are different threat modeling techniques that we use while designing a particular software application. And then testing is was elaborately used cybersecurity. SAST is a static code. The code is static. We don't run the code. The code itself, they read the code, they do the code review, and then they'll give all the vulnerabilities. That is called as a SAST. DAST is dynamic application. So we run the code, we run the application, then we do the vulnerability test. That is called as a DAST. And then IAST, interactive application testing, that we will interact with the application and then see if there are any vulnerabilities are there. Okay. And then penetration testing, so that we will do a simulated attack we do on the particular application and then test whether it's vulnerable or not. And then SCA, it is again a software composition analysis, and we do analyze the code if there are dependent on any third party, and if there are proper licensing through third party, any attack can happen. All the analysis will be done in the SCA. So these 5 techniques we in the industry we extensively follow for the any source codes and then applications, and then we do the testing and then fix the bugs. Okay. In industry, lot of tools are available for each one. SAST, DAST, IAST, penetration testing tab. Lots of tools are available. With these tools, we can do the testing, and then you can also suggest your engineers, your students to go through all these things. Okay, so I will directly go into the smart manufacturing. So smart manufacturing, we had a Purdue model. So we have a level 5, level 4, level 3, level 2, level 1, and level 0. Okay, so level 1 is a very at the corporate level things, and then level 4 is the IT systems, less secure. These 2 are less secure. Then we have a demilitarized zone will be there. So where the security will be very high. So level 3, level 2, level 1, level 0 are very highly secure. So even somebody is trying to attack the manufacturing environment, they will be attacking at the level 5 or level 4 only. So coming to level 0, level 1, level 2 will be very difficult. So this is the Purdue model that we followed in the industry to secure the manufacturing industry. So with this, actually we are very close to the time. So I'll stop. If you have any questions, I'm ready to answer in the both cyber security and semiconductor space.
Sir, we have 30 minutes more, sir. 3:30.
Oh, 3:30, yeah?
Yes, sir. 1.5 hours.
Oh, okay.
Okay, you have sufficient time, sir.
Okay. So then let me spend some time on the application security. Okay. So SAST is the static application security testing. So this run on the static code. You have a source code available in your application. The source code it will analyze and then it will give all the vulnerabilities from just reading the source code. Okay, we won't run the application. Without running the application, just reading the source code, it will do the analysis. Just the code review. Okay, there are a lot of tools are available in the market to do the SAST, and it is very important to run those tools against your source codes to find the vulnerabilities. Okay, now come to the DAST. DAST is running the application. You have a source code vulnerability you found. Now you run the application. After running the application, if you are able to find some vulnerability while the application is running, it is called as a DAST. So, for example, you are building a home. Think about like you are building a home. While building a home, before building a home, you will create a plan. Okay, so there will be a kitchen here, there will be a room here, there will be a windows, there will be a doors, everything. The plan will be created. On just seeing the plan, if you are seeing some vulnerability, that is called a SAST. So you say this windows is there. This windows here, it is very vulnerable because somebody can enter through these windows. You should not have a window here. So just seeing the plan itself, you are doing analysis, right? That is called as a SAST. DAST is like after you built the home, now you are seeing the home, real home. You are going and then seeing the home and then see is there any vulnerable. Okay, this door is very vulnerable because this door we should have a grill gate should be there. Some lock should be there. Okay, here there is a window. This window you should put some, some lock should be put, some grill should be put. Like that, after building the home, you are going and seeing the building and then you are giving the feedback. That is called SAST. That is by software application, you run the application and then you test it and then say these are the vulnerable. And then IAST. What is interactive application security testing? Is you built a home, you saw the home and then you are saying these are the problems. But IAST is like you live in the home. You go there and then live in the home for a month and then see what are the vulnerabilities. When you live in the home, you will see a lot of threats, right? Some people are coming, some people are going. Who are the people going to come? Who are the neighbors? Okay, is there a police station nearby? Okay, so all these, who are the people surroundings? Who are the coming? All these things you will know only by living in the home for a month. Similarly, when you have an application, that application you put the real data and then work in a real-time environment and then see any vulnerabilities can be taken from that. That is called as a IAS, Interactive Application Security Testing. And then fourth one is penetration testing. Here you have a home, somebody is living, and then you try to perform an attack on the home. You behave like a thief and then get into a home and then try to steal something. Similar way, we can attack an application. This is what they call as a ethical hacking. We are hacking the application, but ethically to test the application. They call it ethical hacking. So this penetration testing is done. And the last one is SCA. SCA is a software composition analysis. Your software will be using lot of third-party softwares. Lot of third-party software. So you might be testing your software perfectly. Everything is good. But you are dependent on some other third party. That third party might create some problems for your applications. So that is called as a software composition analysis. This will find out what these are the third party which is problematic, vulnerable, don't use it, or make sure you use it this way, that way, like that you say. Like you living in the home, they say, boss, the person next to your home or the person who's living on your first floor is a very dangerous person. Some third party. Don't depend on him. Don't buy milk from this guy. Don't get newspaper from this guy. Like this, the third party things does by the these all 5 testing is very, very important. And currently in industry, all the software applications are developed, undergoes all these tests. You can definitely give an assignment to your students asking what are different industrial tools are currently in the market, which does the IAST, penetration testing, SCA, and then ask them to use those tools. There are students free versions are available, 1 month, 2 months free versions are available. With that, they can run on their own code they develop, and then they're able to find those vulnerabilities, and that will be very, very useful for the students as well as for the when they go for a campus interviews. It will be very, very useful. Okay. Now I talked about the application security. Now the equipment security. So cyber security, as I told, in semiconductor industry, it came very, very late. I would say it came after the COVID. Before COVID, semiconductor industry never worried about that much about cybersecurity. It was there, but not that much. There is a organization called semi.org, www.semi.org, which is a non-profit organization that connects all the industry players together in the semiconductor, and then they arrive at lot of standards. These standards is followed by the industrial people, by the fab people, by the equipment suppliers, from the OSAT peoples, design peoples, everyone to follow the standard so that the semiconductor ecosystem can interact very beautifully without any problems. They have created so many, more than hundreds and hundreds of industry standards for semiconductor industry they produced. Now recently, they have come up with around 5 to 6 standards they produced. These standards for fab equipments, and then the integration of the fab equipments in the manufacturing environment, and then the specification of the computing devices, and then protocol, communication protocols, and then operator management and monitoring, application whitelisting, like that. They have come up with numerous standards. These standards are available on the semi.org, www.semi.org. You can go, and then these standards will be available. And these standards are followed in the semiconductor industry. So I will go a little deep into the semiconductor fab equipment. See, what the fab equipment does in the E187 is they ask us to harden the OS. What is OS hardening? OS hardening is a set of rules they have given. Around in the Windows, they had around 300 to 400 rules they have given. For example, the password. For any Windows environment, the password should be minimum 8 characters or minimum 12 characters. Some special characters should be there. Some numeric should be there. The password should be changed every 45 days. Okay, and then the password history should not be more than 8. After 8 till 8, the software history should not be repeated. Like that, they have put some standards, some OS rules they put. Like that, for communication, they have put some rules. How to remotely connect the computer, how to remotely put the server, they have put in certain rules. So these rules, if your computer follows, that means it is completely hardened. If it is completely hardened, people attacking on your computer is, the percentage of attacking is very, very less. That is what they called in the SEMI E187. So apart from that, they also put some standards for monitoring each and every equipment and every computer. What are the different logs that the equipment should produce? That logs how to analyze, and then how to find the vulnerabilities from the analysis of these. So equipment monitoring is one of the things. Third one is equipment scanning. They have a lot of antivirus packages. With that, they continuously scan the equipment for any viruses. So that also they do. Fourth one is the network security. They have a lot of network hardening rules are available in the standards. Those network standards are also these followed. So these 4 things: one is network hardening, OS hardening, equipment monitoring, and then equipment scanning. These 4 put together, they make sure the equipment is very secure. Okay, so first one is about the software security, product security. They do the design, and then do those different types of testing to ensure the software is very secure. Then equipment security, I told about the OS hardening, network hardening, and then equipment monitoring, and then malware scan. So all the equipments, all the SCADA, every system should be scanned properly. Then they called about the smart manufacturing. I talked about OT security, IT and OT integrated security they do, and then they do vulnerability assessment, OS patches, OT security we follow. So combining all these three things, they constitute the cyber security for the manufacturing environment. Any questions, sir, so far? I'll give a gap for some time so that if you have any questions or if you need any other topic, I can continue. From the semiconductor manufacturing and then also from the cyber.
Participants, if you have any queries on cyber security and semiconductor devices, please clarify your doubts with our expert. If you have any questions, kindly you can post your queries or questions in our chat box, please.
So this might be a very interesting topic for you guys. You see that worldwide revenue is 553 billion in 2023. Okay, Indian share out of 453 billion, Indian share is going to be 7.7 billion, and we expected to grow at 8.31% in India. So from 24 billion, it's expected to go to 110 billion in 2020. We already in 2025 is old data. So this much growth is happening in India. So that means India is going to have around 10 different fabs that are already in progress. So you can think of how many opportunities they are going to come. If you see that computer science engineering, electronics and communication engineering, electrical and electronics engineering, mechanical engineering. These are the 4 streams which are going to benefit a lot from these job opportunities. So what are the opportunities? The manufacturing execution system. Manufacturing execution system is a software that is used on the manufacturing environment to ensure the productivity, to ensure the tracking of the manufacturing. It's a very huge software. So we have a lot of opportunities, MES, and then equipment, software and firmware development. The equipment, whatever the equipment we are used for the semiconductor manufacturing, that requires a lot of software. So that software development, and then the normal application development, cyber security, cloud engineering, and then circuit designer. Circuit designer is this is what the VLSI design, circuit engineering. We had a lot of opportunities, and then system engineering. System engineering is the mechanical engineering students. Okay, because the equipment I told it's a very huge in nature, very huge, very big. It will be the one equipment may be of your 1 bedroom size. Some equipments may be of 2 or 3, 4 bedrooms combined together. Such a big equipments are there. Photolithography equipments will be very huge. So such a huge equipment, if you want to design and manufacture, you need to have a lot of mechanical engineers also. So these are the engineers which will benefit a lot in the job opportunities, in the coming job opportunities. Having said that, okay, right now if you see most of the engineering colleges, the computer science will be filled very fast because they get the good placements and then good salary. Okay. The second is I think electrical and electronics, and then electrical and communication. But this electrical communication, electrical electronics is the core industry where the job opportunities are very high. They may not be getting the same salary like computer science students, but over a period of time, after 10 to 15 years, the salary what they are going to get for the electronics, the core industry will be very, 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 very higher than the computer science students. So these things that freshers or the college graduates are not understanding because they are all going for the pure software job, but they are missing the core. Once they become a 10 years or 15 years, 20 years experience, then the amount of job they are going for the electronics and communication, the circuit engineers will be very high, and they will not be losing their job. That is one of the important things we should tell them, because computer science people might lose their job if they are, because there will be some reductions will be coming, so a lot of things will be coming. Because the new people coming into the batch, they can replace them. But the circuit VLSI design peoples, the circuit engineers, the mechanical engineers, or these MES application equipment software development people, they will never lose their job because their knowledge is very, very important. Somebody cannot come and immediately replace it because the experience plays a very critical role. So I would strongly recommend these people to take these, semiconductor industry jobs instead of a normal software application development job, testing job, automation job. Okay, this plays a very good important role. Okay, so normally what the industry is there means, normally what they do is they'll come to the campus, they select the engineers, and then they'll go and train those engineers. It will take almost a year to train a particular engineer in the semiconductor industry. It will take more than a year. So what they do is they do on-job training. They'll give 3 months of training and 3 months of on-job training. After 6 months, they'll deploy into the project, but they will not be very productive. They'll be doing a very, very small job. After a year or two, they start becoming very productive actually. So that means the industry has to invest on these people in the first initial period, 2 years, 2 to 3 years, they have to do investment. After 3 years only, they become very, very valuable and they cannot be easily replaceable. Okay. So what currently people are doing is semiconductor industry, especially in semiconductor industry, what they are doing is they are hiring in the last year itself and they are conducting the internship program in the final year itself because they want to reduce their training period when they come as an employee into the organization. Okay, so there are a lot of industries. They come to the college. They do these curriculum. They have a curriculum like semiconductor manufacturing process. They teach semiconductor equipment engineering. What are different types of equipments? What are different processes are followed? What are different technologies are used? And then the semi.org. I told right. The semi.org. You can go and take a look at it. Semi.org. Okay, so this semi.org is having lot of standards, and this is having lot of courses also. These factory automation standards are very, very essential for the engineers to work on the semiconductor field. Okay, be it in a manufacturing environment, be it in a fab equipments, or be it in a design industry, or be in the silicon manufacturing industry, or in the PCB design, everywhere these factory automation standards will be very useful. And this is not taught in any institutes or any private training centers, nothing it is because it's a licensed standards that are available in the semi.org. But they have a semi universities are there. Those universities are teaching those standards, and the students, if they are interested or professor they are interested, they can go and learn those standards so that you can teach those to the students in the college. And they have a courses for cyber security also, and semiconductor standards, semiconductor manufacturing, everything they do. And one of the most important thing is yield analysis. Yield analysis, if we have a wafer, and that wafer will be how many chips are manufactured per wafer. For example, one wafer gives 100 chips. So every wafer should convert into 100 chips. If suppose only 90 chips are coming, means the yield is only 90. That means 10 chips will go waste actually. The yield is very important. The yield is where the lot of AI, machine learning, and then artificial intelligence are coming into picture. We have a lot of statistical process control, advanced process control, and a lot of yield analysis, machine learning, AI algorithm, pure software people, lot of people are working in the yield analysis. It is a very huge science and it has been one of the bigger topic. Lot of software products have been made on this. Pure software, nothing to do with any electrical electronics, pure computer science software products are made. And most of the technologies that are used are the C#.NET, and then object-oriented design, analysis and design, and then UML is used, and then C++ used, and recently Python's programs are used actually. Okay, so now industries are also giving work, live projects are going on, all these things. Okay, so if you see this now, 3.85 billion, already we are shortage of people on the semiconductor industry. Lot of people are there. So 3.85 million career opportunities are there by 2033. Okay, so currently 17,500 filled jobs. So many unfilled jobs are available, already available in the market. Okay, so 80, so many 1.6 billion and then 1.4 unfilled jobs are going to come. So the major challenge now the semiconductor industry is facing is the talent, availability of talent. Even the talent people are there, they are not ready to take the semiconductor industry because they have to learn for a 2 or 3 years. Okay, it is not like that you go and do some program and then deliver it, or do some coding or testing, you deliver it. No, it is not like that, because we need to understand the domain, we need to understand the equipment, manufacturing, product. That will take 2 to 3 years. So industry has to train a person 2 to 3 years before they're getting 100% productive out of the people. One is people are not ready. Second thing is people are not available. Both are the challenges actually. So that is why I'm telling you, these electrical electronics peoples, the circuit engineers, they have a huge amount of opportunity, but they start low. Low in the sense low package. They might be getting less than 5 lakhs or less than 6 lakhs they'll be getting. But over a period of time, their salary is going to improve and then they'll have a job security. Okay, you don't believe, in USA people at the age of 70, 75 are still working in the electronics because there's shortage of job people coming in this. So we strongly recommend people to take up the career in the semiconductor industry and then learn these technologies, and then make use of this opportunity. I will tell one more information also. So we do a lot of campus interviews. We go to the lot of colleges. We do campus interviews. What do we expect from the people is, so for the semiconductor industry, so definitely we need at least one programming language, at least one. Okay, one programming language where they are able to do small programs and they're able to clear the interview. Second thing is good communication skills. Communication skill means it's not a speaking good English. It is understanding of what we say and then they are responding accordingly, relevantly. It's what a communication skill. It's not a good English speaking, is not a good communication. First is understanding the problem, whatever you are telling, whether he is able to understand it. Then is it able to respond to that in a relevant way? No, that kind of communication skills we are seeing very less in the from the engineering colleges. But over a period of time, the people develop that, and the programming language, and then attitude and behavioral skills. So attitude and behavioral skills is very important in semiconductor industry because it's a kind of a manufacturing kind of industry. So we do a lot of punctualities, and then behave like they have to behave like a student after coming to the office also in another 1 or 2 years. Then slowly they can get well with the profession. Okay, so finally I'm concluding, like we conduct semiconductor training. Okay, semiconductor training on all these topics, semiconductor manufacturing process, semi equipment engineering, and then all the factory automation standards which are relevant to the software and then manufacturing we take. Also for the mechanical engineering and the yield analysis, we do a lot of AML programs, how yield analysis is done, how data security, data analysis is done, what are different types of model, how the yield is controlled in the thing. So we take a manufacturing execution system, MES software training also we give. And then we give C#, .NET, OAD, EML design patterns training, C++, Python, embedded systems, embedded programming training also we are giving to students. If your students are interested, definitely we are willing to train those people actually. Okay. Any questions before I conclude? If you have any questions, you can please ask. Okay. If there are no questions, I'll just conclude it. I am actually member of a MEL Trust. Okay. MEL Trust is a non-profit organization which do lot of service to the society. They do lot of services like healing people who are having any diseases like cancer or all other diseases which cannot be curable. We do service those people and then cure those diseases. Actually, we do healing. This MEL Trust is also conducting lot of training programs for the underprivileged peoples and the poor people, needy peoples. One such initiative, we are doing a lot of software training and then semiconductor training also for these people actually. Okay. If you guys are interested or if the students are interested, definitely these are the contact numbers. You can contact us for any kind of support, any support services that you need. You can definitely reach out to me or reach out to these numbers. Okay. So with this, I will conclude my training and thank you very much for patiently listening. And definitely, if there are any questions, you can reach out to me. This is my WhatsApp number, and any help, any assistance, definitely please reach out to me.
Thank you, sir, for your enlightening presentation on cybersecurity challenges and semi-standards in fab environments. To propose the vote of thanks, may I now invite Dr. G. Kandiban, sir, a professor of Science and Humanities Department.
A very good afternoon to one and all present here. That is for the right time to propose my vote of thanks. Thank you very much, Engineer Gobi Gavaskar Pandian, sir, for your insightful, enriched knowledge session on cyber security of semiconductor fab equipment, semi-standard practices. Your presentation provides a comprehensive understanding of the cyber risk associated with the semiconductor fabs and the importance of semi-standards such as E187, 188, 191, and E192 in establishing a robust cybersecurity framework. Your clear explanation of threat modeling methodologies like STRIDE, FASTA, and VAST, along the detailed discussion on security lifecycle practices, gave participants value of perspective on industrial protection strategies. We was particularly impressed by your practical illustration of IT-OT convergence, the Purdue model of smart manufacturing, and a necessity of malware-free integration access management in critical fab environment. Your example connecting real-world cyber incidents in major global fabs to preventive practices truly highlighted the urgency and relevance of this domain. On behalf of the Department of Electronics and Communication Engineering, Internal Quality Assurance Cell, and Institution Innovation of Council of Sri Satyam College of Engineering Technology, we extend our heartfelt gratitude to you, sir, for accepting our invitation and delivering such an engaging and technically enriching session as a part of our AICTE sponsored ATAL FTP. Your expert insights have broadened our understanding of how cybersecurity plays a foundational role in the semiconductor industry's evolution towards Industry 4.0 and smart manufacturing system. We sincerely thank you once again, sir, for your valuable time and inspiring delivery and your contribution to this faculty development program. Thank you. Thank you for giving me this opportunity. Thank you, Nada.
So thank you, sir, for your kind words and for proposing the vote of thanks so gracefully. Now,
thank you.
Thank you, sir. Now yes, sir. Now we move on to the technical session 12. Good afternoon, ma'am. Shall we start the technical session 12, ma'am?
Yes, sir. We can start, sir.
Thank you, ma'am. Very good afternoon, one and all present here once again. To introduce our distinguished expert for the technical session 12, may I now invite Dr. N. Tamilchelvan sir, HOD of Mechanical Engineering, to do the honors. Please, sir. Sir, your voice is not audible. Please unmute your audio.
Yes, sir.
Now is good. Okay.
Yeah, yes. Thank you, sir. Good evening to all. It's immense pleasure to introduce our esteemed expert for technical session 12, Mr. S.V. Siriraj, Director of Technical and Operations at MCOG Solutions, Chennai, Tamil Nadu, India. Mr. S.V. Siriraj is a university rank holder with an Master of Engineering in Power Electronics and Drives from Anna University, Chennai. He has accumulated over 13 years of industrial and academic experience in various organizations, including Honeywell Automation India Limited, Top Systems Private Limited, Sri Venkateswara College of Engineering, and now presently he is working in MCOG Solutions, Chennai. At MCOG Solutions, he heads the product development, manufacturing, and testing divisions, and focusing on electric vehicle testing systems, low voltage boost converters, and software defined vehicle architectures. He also serves as a program mentor for the executive PG certificate program in electric vehicle design certified by IIT Roorkee. And also his technical achievements include the design and delivery of DC-DC converter for Raspberry Pi and IoT devices in collaboration with IIT Madras. Presently, is ongoing research work with CVRD and DRDO on aircraft generator control units. And he has also authored interactive books in embedded C programming aimed at empowering rural students to develop practical software solutions. Today, Mr. S.V. Siriraj will share his rich expertise through a session on applications on semiconductor technologies in real world to IoT and AI systems. The session covering smart home automation, architecture analytics, healthcare systems, and Industry 4.0 solutions that seamlessly integrate artificial intelligence and semiconductor innovation. Sir, we are truly honored by your presence. We extend a warm welcome to you and look forward to your inspiring presentation. Once again, I welcome to our expert, Mr. S.V. Siriraj, for this session. Thank you for giving me this opportunity. Thank you, sir.
So thank you, Dr. N. Tamilchelvan sir, for the warm and detailed introduction of our expert. Now, with great pleasure, I invite Engineer S.V. Siriraj to deliver his talk on the practical applications of semiconductor technologies in Internet of Things and AI. Sir, the session is yours.
Yeah, thank you very much, sir. So first of all, good afternoon all. And thank you, Satyam Institutions, for giving us this opportunity to deliver a talk in this particular topic. So let me share my presentation.
Yes, sir. Sir, if possible, please kindly turn on your video also.
So I hope you are able to see the screen.
Yes, sir.
Right, sir? Yeah.
Yes, sir.
So the topic is, we are going to discuss about applications of semiconductor technologies in real world IoT and AI systems. And we will take a couple of case studies in smart homes, agriculture, healthcare, and Industry 4.0. Now, when we talk about applications of semiconductor technologies, we have to see that what we had earlier, what semiconductor technologies we had earlier, and what opportunities we got in these days to improvise our solutions, in particularly in IoT and AI systems. So that's what we are focusing, and we are taking some couple of exercises, and also I'll take you to the manufacturer websites to show you some of the solutions what they have with the recent semiconductor technologies. So first, before I begin this, I just want to give you some idea about some brief about IoT technology, and make sure that you understand what is existing right now, and then we will then come again and see what improvisation we are able to see in recent days because of the new semiconductor technologies. So we all know that first industrial revolution happened around 18th century, and where the steam engine was invented, and we were trying to do the transport. We started the business or moving goods from one place to another place because of the steam engine. And in 19th century, we invented electricity, and we got petrol, steel, and so many things. And then we started assembly lines, and we started mass production as well. So we were, getting more labors, and people are getting job because of electricity, and because of electricity, the mass production has happened. And when you look at the third revolution, we got electronics and IT. And there we started the production in a mass volume. We increased the volume. We increased the business quantity. We increased the number of business by automating certain things. So wherever critical, wherever more delivery is focused, wherever the speed of delivery is focused, we're trying to automate it. So because of electronics and IT. So this was our third revolution. And in the fourth revolution, we introduced intelligent production. So intelligent production means we wanted to make sure that the production is more effective, and the product should have around 0 defects. And if we wanted to do all these things, we need data. And we need to analyze the data. Without data, no companies can initiate any decision. So we need to have some data. So we were trying to capture data, and most of the times our sites will be remotely located, correct? So let's say we have a petroleum site somewhere remote place, and I want to sit in my office and analyze whether the production is happening efficiently and effectively. So that means I need to get data. To get data, I cannot travel to my site every time. So we wanted to hook up the data from the site to our place, to our server or data server. So this has been done to increase the effectiveness of the production, which is called intelligent production, where the decision is taken based on the true facts. So earlier, some people in the management, top level management, they decide, okay, you do this, or you do that, or you don't do this, or you don't do that, without having any factual data. But for an industry, obviously they need factual data. So to get the factual data, we need this technology, which is called IoT, and we have data analytics tools to take data and stream the data properly, so that a top level management can see what is the fact, and based on the fact, we'll be able to take the next step. So in Internet of Things, we call IoT Internet of Things, means that anything is connected to Internet. A thing which is connected to Internet is called as Internet of Things. So that means necessarily that thing means normally a sensor, probably a sensor, right, which sends information via Internet. So that is what a simple idea about what is IoT. So for example, I have a temperature sensor somewhere in remote place, and the data is there in the temperature sensor, correct? So because the sensor will be connected to a microcontroller, and microcontroller will be there in the site. Temperature sensor will be there in the site. But I don't want microcontroller. I don't want to see temperature sensor. I just need data. So what we do, we normally push the data into some web server, a cloud server. And here from sitting in the office, I'll be accessing the cloud server. And then I'll be taking the data into my PC, local PC. Right? So this is what we were doing with IoT devices. And another thing, that we can do a lot of computation intelligence. We can bring many computational intelligence. So for example, if you take let's say, the Amazon delivery. Let's take an Amazon delivery, if something like that. Let me see if I have an example for that. Yeah. So let's take a logistics delivery, where the product is starting from the distributor. Let's say a distributor will be there in somewhere in Ahmedabad, somewhere, let's say. And by sitting in my home, I'll be able to tell you that today where my parcel is, where it is there in Pune airport, or whether it has reached to Chennai hub, or whether it is in transit or not in transit, or not dispatched. So I'll be able to see the status of my product. So this is one of the example, or the level of effectiveness of delivery of a product is increased because of these IoT technologies. And if you take cars have GPS, cars have cellular network. So all these technologies which is sitting inside the car is making you so comfortable. And how do we send data? So conventionally, you all know that we have the sensors, we have the microcontrollers, and from sensor the data goes into the microcontroller, that is called embedded systems, and from microcontroller it goes to the cloud, whether it could be Amazon web server or anything, any web server, right? And that server is installed in your computer, which is called front end. And in the front end, we will have some graphics, or we call HMI, human machine interface, where you'll be able to see the dashboards, the levels in a very beautiful way, or a kind of a presentable way. So we have sensors, we have microcontrollers, then the data is sent to your cloud space. From the cloud, it goes to your front-end computer, where you build the HMI, and the people who wanted to analyze the data, they can access that data and do it. So this is what we were doing these days. And we have some connectivity. We'll send this data through GSM. That is also possible. Okay, so for example, we got a project from a company to make a pallet. And this pallet is nothing but a carton box, something like a carton box. And this carton box, they are actually dispatching around 1 lakh carton box around the country. And this carton box will be moving in transit, or sometime will be in the warehouse also. And this company wants to know where exactly right now the particular carton box is available, whether it is in transit, if it is in transit, which location, or whether it is in warehouse, of which warehouse. So we need to pull the latitude and longitude and give to the customer. But in certain cases, we cannot use Wi-Fi, because you will not be able to connect that particular carton, which has the IoT device, cannot be connected every time to Wi-Fi, right? Because it is moving, it is not sitting permanently into a place. So if it is sitting permanently into a place, we can connect to a Wi-Fi. But if it is not connected, sitting in a permanent place, it's very difficult to connect the Wi-Fi every time. So in that cases, we have we use different connectivities. So in this case, it's a possibility. We thought about GSM, and it worked out. So the connectivity, you can establish the connectivity based upon what kind of purpose your IoT device wants to give to the customer. Okay, so that's how. So this is what existing right now with IoT technologies. Now let's move in understanding what exactly the responsibility of semiconductor. We all know that semiconductor technology is nothing but the backbone of even all modern digital systems. Okay, so if you look at modern digital system, we have chips, that is ICs, then SoC, which is called system on chip. That means in one chip, you can have a computer, like a microcontroller in a chip. GPU, the graphical processing unit, graphics. Your PMIX. PMIX is very important thing. Right now, people are working on PMIX for those products where you wanted, which is actually moving, and you wanted to give backup for long days. So, for example, if I take the carton box example, the carton box will be moving around the country. Even for 6 months, it will not come to my hand. So that means for that 6 months, there is no provision for giving current to the battery. So that means the battery should be, and there is a restriction for the battery also, because the battery has to be very small. Otherwise, the device will go big and the people will reject it. So the challenge over there was your battery should be very small. Okay. And battery, we can find a battery which is very small. That is possible. But think about that. We need to power with a small battery. So probably a 2 AH battery, or maybe 1 AH battery, assume. And you need to power all the electronics in the carton box. Your microcontroller will be there. So probably your GSM will be there. And you need to power up it for 6 months. So here we cannot think our normal semiconductor technologies to handle this kind of activity. That's very difficult. So we need to find latest new modern technologies, semiconductor technologies, which will help us to solve this problem. And semiconductor technologies which solve these problems, which comes under the category called PMIC. It is called power management IC. Okay, so just for managing the power, remember, for managing the power itself, we have an IC. So see what is the criticality of that sort of applications. Then communication ICs. For example, we wanted to establish CAN communication, or maybe I2C, UART, SPI, or FlexRay, or MOST. So many communication protocols we have, and today we have the semiconductor technologies to provide all these communications. Now, how this semiconductor technology, which sits in IoT and AI, will give you more efficient automation, or energy efficient and performance efficient application. So one is that semiconductors, obviously, you know that in IoT and AI applications, we need to do computation. We need to do a lot of calculations, right? So that means the semiconductor should be more efficient. It should consume very, very less power. And we also need some sensors to give data. So see the sensor should be very small. The sensor should be consuming very, very less power. And we have the connectivity devices or connectivity ICs. So these ICs should collect data, and this should exchange the data. And this also consumes power. This also handles so efficiently, and it has to be very small. And some AI algorithm should sit in the IC, and that also should work. So that means the semiconductor is taking, or is giving the shoulder to IoT devices like microcontrollers, your PMICs, your sensors, and for AI. Okay, for doing AI, it also giving the shoulder. So it is carrying everything. So if you want to do a better IoT and provide better IoT and AI solution to your customer, you need to think about how your semiconductor is going to give an efficient solution to this problem. It doesn't mean that if you think an IoT and AI, like we need to, let's buy some IoT controller and do something, or we'll choose a random IC. So you can't do that. You need to select a proper semiconductor technology in terms of sensors, in terms of microcontrollers, in terms of power management ICs, in terms of providing AI. So let's see what are the different components which sits in an typical IoT and AI application. So microcontroller, there is no doubt that for an IoT and AI applications, we need microcontrollers, because that is going to handle your entire logics and processing. Then system on chip, which includes your CPU, GPU, memory, and communication units, and sensors. Then PMIC. PMIC takes care of your voltage, regulate the voltage, and optimize energy use. And communication ICs, as I said, Wi-Fi, Zigbee, LoRa, 5G, and so on. And to do the AI, there is AI accelerator inside the chip, and that takes the deep learning inference. So these are the building blocks which is there in semiconductor technology, which solves IoT or which provides IoT and AI solution. So where are we in IoT now? Now, as I said, that we take data and we send data to the cloud. And since the controller has to be very small, we don't have more computing power also. So whatever the existing technology we had earlier, the IoT devices will hang or will get heated up if you try to do more computation. So what we try to do in most of the cases, we don't do any computation within the IC. We'll try to capture the data and we'll send the data to the cloud. And we'll do the computation in the cloud itself, or maybe your host computer itself. Then advances in the semiconductor design now allow edge computing. So there are two types of computing we normally do. One is called cloud computing. One is called edge computing. The difference between cloud computing and edge computing is, cloud computing means you push the data into the cloud and you do the computation in the cloud itself. But for the cloud, you need to spend money, because, for example, you want to buy a server and you need to spend server, and that is a recurring cost. It's not a one-time cost. It's a recurring cost, because as long as you have even 5 customers, you need to use the web server. You need to rent out or get the web server. So it's a recurring cost for a company. Now people thought, why don't we do the computation within the IC itself? So let's make the semiconductor technologies in such a way that let the semiconductor technology get the data from the sensor and put the data into the memory, and let it do the computation. Let it do the AI algorithm inside it. So that is nothing but the edge computing. So companies like NVIDIA, Jetson, NVIDIA, Jetson, Google, and Qualcomm, Snapdragon, they all are doing, or they are having, IoT and AI edge computing ICs, a single IC which can do all these activities. So that means you don't want to spend for your web servers. You don't want to, you can avoid the recurring cost, and you can use the IC to do the computation for AI algorithms. Then coming to the PMICs. So as I said earlier, power consumption and long battery life. This is very critical, but it looks like very simple for us. But still, when you design a portable applications, when you think about a portable applications, it's very difficult to, because we don't know, when the battery lasts. And if the battery lost, your product is lost, right? So in a portable device or portable product, when you have an IoT device, you send your product is gone with the IoT device. And if the IoT device loses power, the GSM doesn't get power, the microcontroller doesn't get power, right? The GPS doesn't get power. So you'll not get any data. So we wanted some intelligence in the power, handling power itself. Earlier, we were trying to do intelligence in computation. But right now we are thinking, or people have thought, why don't we give some intelligence in handling the power itself? Now, how do you do that? So that is what this PMIC is all about. So power management ICs, basically these ICs uses low leakage transistors. They do adaptive voltage scaling. Low leakage transistors. What is the advantage of low leakage transistors? Anyone? What do you mean by leakage current in a transistor? Anyone? Do you have any idea about leakage current in a transistor? Any answers from the participants? Okay, so leakage current in a transistor means, so normally a transistor should conduct current when it is on. But when we switch off the transistor, there will be a current flowing, that is called the leakage current, correct? So if the leakage current is increased, what will happen? The battery will get drained. For you, as a designer, you may think that, okay, my device is off. Your device is off so that the power is not consumed from the battery, but it is not true. Because of this high leakage current in a transistor, the current will get drained from the battery and battery will get lost. So we need a semiconductor technology to handle or to make a power management IC which uses low leakage transistors. Then adaptive voltage scaling. Adaptive voltage scaling means, if you look at a battery voltage will be constant every time, right? So if suppose the current is taken from the battery, obviously the battery voltage will get reduced. But adaptive means, if suppose I want to give you very less current, I can make my output voltage to be lower. I can reduce my output voltage. If I want to give, because we know that current is nothing but potential difference. If high potential difference, obviously more current flows. If somebody is asking, some IC is asking very small amount of current, I can reduce my voltage and give current. So this is an effective idea that to reduce the leakage current or an unwanted current flowing into the circuit. If I try to reduce the voltage as much as possible, the load cannot draw more current. If the load is trying to take more current, the current will not go beyond a point. So that means you unwantedly you will not lose current. This is called adaptive voltage scaling. Then ultra low power sleep modes. Ultra low power sleep modes means that we can make the battery to sleep. Okay, we can make the battery to sleep. Okay, we can make the controller to sleep whenever we don't want it to get activated. For example, in my pallet case, the customer wants every day 5 messages to tell where exactly the pallet is. So probably they'll say send me every 4 hours or 5 hours. So that means once I send 10 o'clock, next I have to send it at, let's say, 2 o'clock. So that means I can sleep for another 4 hours. So my battery can sleep, my controller can sleep, right? So the power consumption or the loss of power or leakage all can be reduced. So the PMICs are developed using a technology, semiconductor technology called FDSOI, which is called fully depleted silicon insulator. Basically, they use very thin silicon oxide layer to develop these semiconductor technologies. Now we'll take a small application about smart homes. Okay, so application of semiconductor technology in smart homes. So in smart homes, so basically we wanted to sense or detect the temperature of the house, humidity, air quality, and motion sensor, right? So this is one set of activity. The second set of activity is that we also need to do some processing and control. So obviously we need to get MCU, microcontrollers, where we write the logics. Then we need to have a connectivity, and then we need to have an actuation. Actuation means nothing but an output device. kind of an actuator will be a relay or maybe a transistor. All are actuators. Recently, if you would have seen Google Nest. So basically, Google Nest is an ARM-based single system on chip for for data processing. Basically, this is a thermostat, a smart thermostat, which was designed by Google, and it is called Google Nest. So basically, it's a single SoC, a system on chip. It's a single chip that integrates sensing. So just think about earlier we have sensor outside, we have processor, we have a connectivity outside, we have cloud outside, we have everything outside. So all put together, right now we have one device, okay, so which has the sensor, which has the CPU, which has the memory, which has the communication, and which has the peripherals. So all put together, this device is called smart thermostat, which is one example of Google Nest. So what it does, it reads temperature, it reads humidity, it reads motion, it reads ambient light sensor to determine what comfort level based upon outside intensity lux level or sunlight. We'll be able to control the room lighting, correct? So that's what it does. So it has sensor, data processing, then connectivity. It communicates with your smartphone, or you can have your cloud servers, okay? Then it has AI. So AI will understand your habits, basically what is your comfortable temperature, okay? What kind of ambience you would like to have, lighting ambience, temperature ambience, humidity ambience, okay? And it controls the heating, ventilation, air conditioning, HVAC system through your smart interfaces. So basically, if you look at in HVAC, we normally control the temperature based on the room temperatures. For example, we keep temperature to be a fixed temperature value, let's say 25 degrees Celsius. When more people come into the room, obviously the temperature will get increased. Then we'll try to increase the cooling, correct? So that's how we were doing, right? So the same thing right now, because of this algorithm, we'll be able to do more effectively. Then we'll see semiconductor role in agriculture. So if you look at in agriculture, we have many problems, many challenges, right? And we always say that agriculture business is a lost business because water scarcity, not able to monitor, because if you want to get at least a decent income, you need to have at least 5 acres of land. In 5 acres of land, how do you monitor everything? And we also, most of the farmers, they have a sort of experience or knowledge which they got from their ancestors. But today things have changed. Probably our ancestors would have said like, we have to do like this, but that is based on the weather or the conditions at that time. But right now, the temperature or the weather in our country is not as similar to that of what happened 100 years back. So everything is changing. Pollution is increasing. There is poor quality of water, poor quality of air. So many things are there. So today we don't have data. We don't have proper data, that factual data. And people are driving agriculture without having a factual data. This is one challenge which is in agriculture. The second thing, that since you need to do at least a very big volume, then only you will get at least a decent income. More amount of land, you will not be able to monitor on your own. And you cannot employ many people in this business because it's not a very big profitable business. So here, if you want to make it more effective, more controllable with monitoring based on factual data, you need to bring IoT into agriculture. So that is the need for agriculture. So basically, semiconductor has a very great role because the IoT ICs are made up of latest semiconductor technologies. So what are the sensors we have? So semiconductor based sensors, we have soil moisture sensors, we have pH sensors, we have nutrient sensors. Okay, and all these sensors will pick data and it will send the real-time data from the field to your phone, and we have or to the microcontroller, and you can write algorithm and you can decide what kind of nourishment you need to give to your plants based on different types of plant, because we always believe a similar kind of nutrients for all plants. It is not so. So based on the conditions of plant, based on even the size of the plant, right, based on the type of the plant, based on the soil, whether this plant will go in this particular soil, or what is its growth in 25 days, whether it has acquired that growth or not, right? So all these things we can put into, or we can collect the data using sensors, and we can process. Process means you'll write an algorithm what you want, and you'll compare with the actual data, right? And then you can take a decision that whether you wanted to give more nutrients or different kind of nutrients or different levels of watering and so on. And sometimes we know that when we go into the fields, we'll understand that sometimes the leaves would have being in a different color, or leaves will be attacked by some disease, and will not be able to identify what exactly it is. Okay, and what we do normally, we just leave it as it is, or maybe we cut the plant. So now, because of AI chips, we can also take image-based decision. Okay, so we can take the image of that crop, and you can detect what exactly the problem with the leaf, and how it is going to get affected the plant, and what kind of decision we can take in order to help the plant. Okay, so all these improves the yield of agriculture. So I'll take you to microchip technology. Microchip technology has variety of products in agriculture, especially in this IoT. Okay, so if you look at here, so they have many ICs, to revolutionize your smart farming. Okay, like detecting the plant disease, and even for the supply chain challenges also. Let's say, how do we deliver? So sometimes you would have seen we have more stocks in the warehouse, right? The potato, normally, tomato or potato cost will go very low at some point. And how do we solve this supply chain? Okay, so people will keep it in the warehouse, or sometimes we could see the tomato cost will go high, right? So these are the issues happens because of the supply chain challenges. That's what I believe. And this also can be solved. Okay, so based on the need of the people, how much it is needed for this particular state. Okay, and what is the temperature we need to maintain in order to maintain that particular fruit, correct? So even if you look at most of the time, if you take Bangalore does not have any coastal areas. All fish and everything which comes either from Andhra or from Chennai, right? So this, if suppose they maintain a temperature of -5 degrees Celsius in order to transport the fish to Bangalore. If suppose the temperature changes or the temperature increases, obviously all will get spoiled down. So these ought to be sorted so that the business will be more efficient, and you will also do more production, and you can deliver your customer on time with good food, quality food. So that's what the idea of microchip starting so many solutions in the name of smart agriculture, which also supports the logistics, the supply chain activity as well. Now let's look at the healthcare. Before healthcare, I would like to add one more application which is very, very critical, where we are even facing. So let me take you to that problem also, because we are more into electric vehicle. So I would like to give you a factual, problem which people face today, and which needs a great attention of semiconductor technologies to solve this. So you all know that batteries are manufactured, and the batteries which we use in vehicles are more dangerous. And if suppose the battery is not functioning in the middle, it's very dangerous even. Correct. So let's say if you take a petrol vehicle or vehicle, you cannot expect a sudden problem of not having a fuel. You know that the fuel is going to get empty soon, so that you will find a nearby petrol bunk. But over here, the problem which people are facing, we have battery, and battery have energy, and in the indicator it shows that battery has energy, and we will drive safely, or we'll say, okay, let's go for a 300-kilometer some picnic spot, and you'll check the battery is full. But in the middle, although the battery is full, the battery is not get emptied, but there is a problem comes that the battery suddenly stops working. So this is a great problem which we are facing. So remember, the battery is full. When I started, battery is full. And when the vehicle stopped, the battery is not emptied, although it got stopped. So this issue was a very critical issue which we have faced. And let me show you some pictures of that. The battery packs, how it looks like. Let me show you this is from a company, the manufacturer of battery management systems. So they have their products are mostly used in many of the battery pack designs. So if you look at a battery pack, simply look like this. Okay, so this is how when we make a battery pack, it looks like this. Okay, so this is how your battery pack of car looks like. Now the problem is that this battery pack is filled, and if you see the voltage before you start, the battery will be full. But in the middle, the battery doesn't function. Remember that the battery is not emptied. Now tell me, can anyone tell me what would be the problem happened so that the vehicle got stopped? The battery is not emptied. Okay, the battery, when I started, the battery is full. What could be the problem would have caused so that the vehicle got stopped in the middle? Can somebody? I wanted to be interactive so that I'll assume that this is a fruitful session to all. Can somebody tell me what could be the anyone? Just give your idea.
Some reasons are fuel issues, ignition system fault, overheating. Mechanical issues.
Okay. Okay, sir is saying that there could be some problem in the ignition. Okay, but my question is that there is a problem in the battery. What could be the problem in the battery itself, which has stopped?
Sir, maybe delivering power to some other functioning in the within the vehicle.
No, if the battery is healthy, sir, it is going to power up any parts of the vehicle. There is no doubt at all. Correct?
Okay.
See, battery, when I started, it was full. And when the problem comes, the battery is not drained completely. But there occurs a problem in the battery, which suddenly makes the vehicle to stop.
Maybe loose connections or corroded battery terminals.
Okay.
The weak or failing battery under load.
Okay. Okay. So why we all studied about transistors? Why transistors are having a beta factor? Why the manufacturer gives you beta equal to 99, beta equal to 100, 101? Why can't they give you beta equal to 99? Or why can't they give a beta equal to 100 for all transistors?
Sir, maybe due to overloading of the battery, it may be.
Okay. Okay, we'll see that. We'll see that solution. But can you tell me what is beta factor in a transistor? Beta. We'll be studying like
yes, current gain.
Beta is a current amplification.
Current gain.
Yeah, it's a current gain. But if you look at beta, for certain transistors, you will say 99. For certain transistors, you will say 100 or 101. My question is that why can't we say beta is equal to 99 for all the transistors, whichever we make? Why it has to be different numbers? For some set of numbers, we'll say it is 99. Some set will say 100 or 101.
Based on the applications, we want to choose the transistor with the amplification factor beta equal to 99. In some applications, maybe 101 is needed. Then the system can try. Otherwise,
but you know, 99 and 100 and 100, it is not going to give you reasonable change. Right? There is no reasonable change. Maybe a 1 microamp change. See, the reality is we cannot make identical transistors at all. Although transistors come from the same lot, same manufacturing lot, you cannot guarantee that both the transistors are going to be identical.
So tolerance we have it, no sir? Tolerance.
Yeah. Yes. So there will be slight change in one transistor to another transistor, and that is indicated using beta. So now if you look at a battery also, although it comes from the same manufacturer, maybe in production same lot, we cannot guarantee that all the batteries are going to be, all the cells are going to behave the same way. Okay, so when we make a battery pack, it is the responsibility of all the cells to behave properly. And we also know that all the cells are not going to be identical. So if one harms, okay, the entire battery pack can get gone. So that is the criticality of making a battery pack. So what would have happened is that some cells, maybe 1 or 2 cells out of, let's say, in the battery pack, let's say there will be 200 or 250 cells. Okay. And let's say 5 or 6 cells are not working properly. Right. So if why they are not properly working, because as I said, all are not identical. Each will have a different problems. And before we make battery pack, obviously we test it. There is no doubt at all. But while testing, all will show a better performance. But when lifetime goes, what will happen? Some cells out of the entire cells will deteriorate little bit faster than the other one. Maybe much more faster also. So in such applications, if one or few cells got failed, the entire battery pack will get stopped. So what is the advantage? What is the problem here? The problem here is that you cannot predict when the battery gets a sudden issue. And we can also solve this problem. Can anyone tell me how to solve this problem? You can throw your idea. So the problem here is that out of, let's say, 250 cells, 5 or 6 cells can deteriorate so fast, because as I said, no cells are identical. They may have different ways when handling power or when discharging power.
So, sir,
And
we can
yes, sir,
check one by one. We can check one by one each cell. Then we can.
But
know.
when you check, let's say when you check or when I check, how we can check. Let's say if I go to a service center today, I will check. I'll write in a sheet, and after 10 days, you will check. You will write in a sheet. But there is no method, okay, understanding the history of deterioration of that cell from the earlier to this time. You understood?
Okay,
we are not able to monitor it properly. Okay, if I am able to monitor it properly, I would have suggested you that you have to do a predictive maintenance earlier. Correct? So we need some technologies to sit inside this critical applications, so that this critical app, like your AIs. So AI in an electric vehicle, the very important problem it is solving right now is sitting in the battery pack, analyzing single cell, each cell individually, and ensuring that each cells are behaving daily, okay, every time, properly or not. If somebody is not working properly, it will identify, it will take its history, and it will suggest you for a predictive maintenance. So in that case, you can reduce the breakdown. In industry, we have breakdown, right? So for example, in industry, if you would have seen, when a machine gets breakdown suddenly when we go for an audit, people say that, sir, today the machine got breakdown. And if you look at the breakdown hours, they would have lost one man day. So morning would have breakdown, then the entire day they can't use their manpower. So they are losing the manpower for the whole day. But if you are able to do the predictive maintenance, and that is what the predictive maintenance or maintenance checklist in many companies for machines, they do, periodic checking of each and vitals of each and every machine. Some machines they do it daily, some machines they do it weekly, some machines they do it monthly based upon the criticality of that machine. So nowadays we don't want to do that. If we have AI algorithm will help you to measure all the data. So remember, to measure all the data you need sensor, to do the computation you need the MCU, and to take the decision you need the AI inference. Correct? So this will help you to have an effective product, safer product, a long product, less customer complaint, less breakdown, okay, less losses, revenue losses for the company. So that is the idea of why the semiconductor technologies helps. Along with, whenever I say semiconductor, you need to understand it is altogether IoT, all MCUs, everything together. It is not like AI is solving the problem. Obviously, there should be an MCU to do the computation. Obviously, there should be a sensor to do a better sensing. Right? So everything put together, all made in a semiconductor chips, are doing all these activities. Right? So this is one very, very important application where we work on, and we also got, as a company, we also got a lot of issues when once I was giving a battery pack to my customer, and suddenly I could see that when I made the battery pack, that time we tested and everything is working fine. All the cells shows same kind of behavior, almost same, not equal, but almost same kind of behavior. But when we do a high discharge, a sudden discharge, or a long discharge, each and every cell will try to behave a little bit differently. That, if we are able to monitor, we'll be able to give a proper solution to the customer. That's what all the semiconductor applications in vehicles does. Right. Now coming to the smart medical solutions. So if you look at smart medical solution, what would you expect? Anyone? What would you expect to be more smart? What are we lacking today in medical applications? Because normally, whenever we talk about medical, we think about only doctors. We think about only operation theaters. We think about only the pharmacy. But tell me, how do you want to have an effective in the sense that you need to have a continual monitoring. You need to take decision so fast, right? So normally we get a fever and we will sit with the fever for have some tablets, and then we don't know whether our vital is exactly moving correct. But suddenly what will happen? People will get some breakthrough, maybe a heart attack, whatever it is. So what do you think that semiconductor technologies, including all IoT and AI, should bring a healthy living space to the people? What's your point? What are things we need to improve?
We need smarter monitoring and wearables. That means AI-powered diagnostic tools.
Yes.
Wearables.
First thing we need. Yeah. First thing we need. We all have customized. Whenever people, tech companies, they, like Byju's or any companies, they give you personalized learning experience. So similarly, you need to have a personalized equipments to monitor your vitals, correct? So for example, you want to know your oxygen level, right? You want to know your blood pressure level. So there should be a customized device, which is a portable device, right? So for example, if we have old people in our home and we take the old people to somewhere in a temple or maybe a long drive, right? So suddenly people should not happen anything. So we need to monitor their vitals. So that means the first thing what we need to have in medical is we need to have some very good portable equipments, okay, or measuring devices which measures the critical vitals of a human being. So that is what one thing. Okay. Any other?
Smarter.
Yes, sir.
Dose control, whatever the medicine we are taking during the disease, so that's we have to monitor how much dose we are taking.
Smarter drug delivery and treatment.
Okay. One is that, today I have seen people, they take medicine, when a doctor prescribes a medicine, they put in ChatGPT and they will write like, what is the side effect of this particular medicine? Correct. So So first thing that, okay, tablets, one thing which is, how do you want the tablets to be monitored, sir? In what way your idea is all about? You want to know that the doctor has, the tablets which doctor has given will have side effects, or do you want to check like that, or how do you want?
Sir, kindly answer Sriraj's question, please.
Sir, actually, we want just how much dose we are taking for a particular disease and how to manage the dose. What amount of dose we can take for that disease. So that's we can help with. We can take the help of AI so that we can get a good amount of dose.
Okay.
So that,
Right. So, but again, without in that area alone, I just want to add, not only technology, but the presence of doctor is very, very important there. Because
yes, sir.
that's what I was saying. Whenever I get a headache, I'll go to medical shop. I'll ask them I have headache. Then they will tell some 2 to 3 tablets. Then immediately I'll put in ChatGPT, and ChatGPT will tell some long history, long story, and that also misinterpret people. People to they think that they themselves itself they themselves as a doctor, but rather as you said that once we consume the dosage, we can even monitor whether the vitals have been improved. Correct. So for example, I may have an oxygen level of, let's say, 75%. I've taken some medication and I would like to monitor whether my oxygen level has improved. Right. So as a user, we in medical application alone, instead of taking decision as an user, okay, as a hospital or a doctor, they take this, they can use AI to take much more effective decision. Because even I have seen doctors, when we go today, they will tell one medicine. After 10 days, they will forget us. But they somehow pretend and say that, okay, you just continue this tablet. But again, they will not check our vitals. And this is a bad medication. So the AI technologies can also understand our vitals or give the vital data to the doctors, so that from day 1 to day 10, how it has been improvised, right? Because doctor only believes what we say. Sometimes people, there are people I've seen, even in rural villages, they are not able to talk to the doctor, but doctor just presume that, okay, this is improved or this has to be improved. Like they prefer or they write medication accordingly. So that needs to be improved, especially using all the semiconductor technology. And drug delivery, right? So connected drug delivery. So you can see today we have, like the Blinkit, the Zomato, similar to that, we have drug delivery devices or drug delivery places, right? Then clinical drug delivery devices, right? And we have today imaging devices, special imaging devices to monitor certain critical diseases, right? So these are all very important things in medical applications. Right. So finally, coming to the smart factory solutions. So smart factory solutions, if you look at, let me go to microchip link. Okay. So here in smart factory, we have machine vision, right? So machine vision, basically it gives or it helps you to examine the objects and detect defects. So earlier we have visual inspection. Whenever you go to industry, let's say they make some assume I have seen so many automotive industries which make some mechanical equipments, and when we go there, they would have produced some, probably let's take some nut or screws, whatever it is for the automotive. They have a visual inspection procedure. Just one guy will sit there. He will just look at the screw or nut, and he will say, okay. Okay. And when it goes to the customer end, I have seen in many documentation of industries, when I go for an auditor, they get rejected. Okay. So why this gets rejected in at the customer end? Because we have a rule in industries. If you produce some quantity, you can take some samples and test the defects. So for example, daily I am producing 10,000 pieces. In my process, I'll write like quality system process. I will write like, I will verify only 10%. Okay. So 10% of 10,000, let's say 1,000 pieces, I will verify. So remember, 10,000 you verified only 1,000, remaining 9,000 we have not verified. But the industry accepts that they have done a 100% inspection. But when it goes to the customer side, what happens is that probably from that 9,000 pieces, there would be rejection. Now think about rejection. It's a loss to the company. They have already lost the manpower, and the customer will not repay for the next corrections. And it reduces the confidence of the company, and your order may get lost. You'll get less order. So in this area, there are some technologies which we need to build around to examine the defects. Okay, so this is machine is a big concept, but rather we have so many devices today which is customized for each applications, where you can use AI and ML algorithm to find the defects in the production. And second thing is the robots, industrial robots, right? So industrial robots and motion controls, they are used to automate process. So you know very well that some process human beings can't do it accurately. Okay, so there we can use robot. And today we are using collaborative robot, which is called cobot, where the robot can work along with the human being. So both can work in the same ecosystem. Okay, so it will be, so what is advantage here? We will get faster production. The production can be increased. The defects can be reduced, right? So this is on the industrial robots. And then we have DCS. DCS is called distributed control system, which is like a supervisory control system, which we use in all automation industries. So basically they have many programmable logic controllers, PLCs, okay, and RTUs and other systems, which where you could connect all the sensors, and you can take decision from different end. Then PLC is basically a controller which is customized for, we will give for customized for each plant. Okay, so remember, PLC is like a controller. DCS is nothing but a supervisory control. That means you can as a supervisor, you can control over the system. Let's say you want to switch it on, switch it off, or make the valve to be 100% or 70%. You can do that. So a supervisor can have a control over there. Then we have HMIs, human machine interface. Okay, so here we can observe everything. Okay, HMI, we can observe the performance of the system. As a company, we also develop cell testing systems, and we have HMIs. We develop HMIs for our own purpose. So we'll be able to see the performance of the cells by looking at our office. And then intelligent edge nodes. Okay, that is called for each and every factory floors, we have an edge nodes. Okay, so that is used to address the fault or immediate emergency with respect to the maintenance and process controls. And we have industrial Ethernet for provide a real-time control for difficult or complex processes. And then we have 3D printing systems. Okay, so all these are elements which added to the industries, which is called a smart factory implementation. Basically, the idea of smart factory is just two goals: increase the production, reduce the defects. Okay, almost zero defects. Okay, so that is the objective of having this smart factory implementation. Fine. So let me summarize what we have done so far. So we have seen about how IoT, or what is IoT, right? So we were talking about the first industrial revolution, second, third, and fourth, and we talked about what IoT devices has, and what is the purpose of IoT devices, how it can improvise the computational power, correct, and how it is being connected. Okay, so what are the different electronics needed for implementing an IoT that we have seen in the IoT architecture. And we have also seen one example on logistics, how logistics have been improvised in the last 10 years because of this IoT and IoT technologies. And then we further moved into to understand semiconductor technologies, and we were saying that the semiconductor technologies are giving a breakthrough in the modern digital systems, especially in chip designs, making a single system on chips, GPUs, PMICs, communication ICs, and so on. And we have seen different applications, right? And we also have given more importance to PMICs, because PMICs is one area people are not aware about, and people think power of a device is simply powering through battery. Okay, so we have given more importance to understand PMICs, which is made up of recent semiconductor technologies using FD-SOI, fully depleted silicon insulator on insulator. This is nothing but a thin silicon chip. And then we have seen applications in smart home system, which is, we have seen an example of Google's smart thermostat. And then we have seen in agriculture, what are the challenges we have in agriculture, and how we can, enable, or we can improvise the efficiency of agriculture at the end, to increase the revenue of agriculture. And we have also given more importance to the logistics, right? Logistics of sending the in agriculture areas especially. And then we have seen smart medical application or solutions, where we wanted to think about the customized devices which monitors our vitals, and it can be connected to the doctor, and doctor can remotely watch or monitor the vital performance and prescribe medicine accordingly. And also I would like to add one more thing, which is called wearable health monitoring system. Hope you have seen so many wearable monitoring system, like heartbeat monitoring, then oxygen monitoring, all these sensors, all these wearable, they come like a wearable device. And most of the wearable device has this Nordic RF52840 ARM Cortex controller with Bluetooth enabled. Okay, it's a low energy Bluetooth. Okay, so normally Bluetooth, there are two classification: a normal Bluetooth, which is not there right now. Right now, Bluetooth with low energy consumption. Right. And then we have seen in Industry 4.0, So in Industry 4.0, we were talking about industrial sensors. We're talking about the processing, controllers, all these things, connectivity, then AI accelerator, and especially one area I forgot to tell, power electronics. Obviously, power electronics is the backbone of what we are trying to, people forget about power electronics, but I'll say that power electronics is one great domain which actually empowers the semiconductor. So it's actually the energy for semiconductors. That's what I would say for the power electronics. And then we have seen the smart factory, how we can improvise the smart factory by using machine vision, industrial robots, then connectivities, then decisions, and then the safety and predictive maintenance in a factory system, right? So with this, I'm winding up my presentation. Over to
Dear participants, do you have any doubts on the technical session 12? Please clarify with our technical expert, engineer sir SV Sriraj sir, please. Ma'am, do you have any doubt, ma'am? Please. Ma'am,
Sir?
do you have any clarification?
No, sir, no.
No, thank you.
Okay.
Okay.
Okay. Thank you very much, engineer sir.
Wait a minute, ma'am. Wait a minute.
Oh, okay.
Thank you very much, Sriraj sir, for your insightful and industry relevant system. Related demonstration and explanations, everything to deliver the vote of thanks. May I now invite Dr. U. Vasanthi ma'am, Professor of Science and Humanities Department. Ma'am, please first.
Okay, sir. Thank you very much, Engineer SV Sriraj sir, for your enlightening and practically oriented sessions on applications of semiconductor technologies in real-world IoT and AI system. Your sessions beautifully demonstrated how semiconductor advancements power innovations across diverse domains, from smart homes and intelligent energy system to precision agriculture, healthcare monitoring, and industrial automations. Your discussions on IoT, sensor integration, AI-driven analyticals, and real-time data optimizations provided a deep insights into how semiconductors serve as the backbone of intelligent ecosystem. Participants are greatly appreciated your real-world case studies on IoT-enabled EV system, low voltage boost circuits, and industry 4.0 applications, which clearly connected theoretical semiconductor concepts with practical designs and manufacturing challenges. Your emphasis on energy efficiency, automation security, and AI co-design in hardware highlighted the path towards sustainable and intelligent technology development. On behalf of the Department of Electronics and Communications Engineering, IPSC and ICC of Sri Satyam College of Engineering and Technology, we extend our heartfelt gratitude to you, sir, for accepting our invitations and delivering such a comprehensive, industry-focused and forward-looking sessions of the part of our AICTE sponsor, ATAL FDB. Your expertise and enthusiasm has truly inspired our participants to explore the fusions of semiconductors, IoT, and AI smart sustainable solutions. We thank you once again for your valuable time, your engaging talks, and your contribution to the success of this program. Thank you very much, sir.
thank you, ma'am. Thank you very much.
Thank you, Dr. Vanitha ma'am, for your thoughtful vote of thanks and for concluding technical session 12 gracefully.
Oh, okay. Thank you so much.
Sriraj sir, you can leave. Thank you so much once again.
Okay. Thank you for giving the
College of Engineering.
Yeah.
Thank you.
Thank you.
Participants, the next session, technical session 13, will start very soon. Sharply, we will have the technical session 30 at 5 p.m. All the participants are requested to stay online, please. You can take the
Sir,
technical
after that you have given another one link. So before the
no, same link. 2 times I have posted.
No, sir, I was joined by 1:57 p.m. Sir.
So,
You just check,
sir,
sir.
are you in the okay? No issue, sir. Are you in the WhatsApp group?
Yes, sir. WhatsApp group it is not posted, sir.
Or you want session 11?
Yes, sir. Yes, sir.
Link. Okay. You just go and see in WhatsApp. I will post it. Please.
Okay, sir. Okay, sir. Thank you, sir.
Okay. Hmm? Ma'am, good evening.
Good evening, sir.
Good evening.
Hello, sir. Good evening.
Good evening. Good evening. This is my principal, ma'am, Dr. V. Sujata, ma'am. Ma'am?
Hello, sir.
Yes, yes.
Am I audible, sir?
Yes, audible, audible.
Uh-huh.
Feedback from 13.
Principal ma'am, good evening ma'am. Shall we start ma'am?
Sir, good evening, sir. Good evening, everyone. Welcome, madam.
Good evening, ma'am.
Hello.
Good evening, sir.
Good evening, madam. Good evening.
Shall we start
We
ma'am?
can start, sir. We may
Okay,
start.
okay. So dear participants, once again, good evening to everyone. To introduce our final expert for this technical session 13 of ATAL FDP, may I now invite Dr. V. Seran Sengutuvan, Associate Professor of Science and Humanities Department, to introduce the resource person.
Good evening, everyone. It is a great pleasure to introduce our expert speaker for Technical Season 13, Engineer N. Kumutha, Project Scientist Second at the Patent Information Center, Tamil Nadu, State Council for Science and Technology. Ms. Kumutha ma'am completed her BE in Electronics and Communication Engineering from Government College of Engineering, Pardue, and here ME in Optical Communication from AC College of Engineering and Technology, Karekudi. Ma'am has also submitted her PhD under the Quality Improvement Program at Tyagaraja College of Engineering, Madurai. Ma'am has over 16 years of experience in teaching, research, industry, and intellectual property rights. And ma'am has served as a women scientist B at IIT Patna and later as a women scientist C under the Kiran IPR scheme of the Department of Science and Technology, Government of India. Ms. Kumutha ma'am is a registered patent agent in India and chartered engineer recognized by the Institute of Engineer in India. Ma'am has filled 6 patents in India and one in the United States and has worked with the World Intellectual Property Organization. Ma'am has also delivered many talks on patent awareness and innovation under the National Intellectual Property Awareness Mission. In addition, ma'am has collaborates with the NITA resources and supporting innovation, consultancy and IP training program for researchers and startups. Today, ma'am will speak on the topic, how to register a semiconductor IC layout design IP in India, explaining registration procedure, government initiative and real-world examples of semiconductor layout designs. Ma'am, we are delighted to have you with us this evening. We extend a warm welcome and look forward to your valuable insights. Thank you, ma'am.
So thank
Welcome,
you. Thank you, Dr. V. Seran Sengutuvan, sir, for the wonderful introduction of our expert. With pleasure, we invite Engineer N. Kumuda ma'am to share her expertise on semiconductor IP registration and policy perspectives. Madam, the session is yours.
Good evening to all, and thank you, sir. Thank you, Dr. Kannan, sir, and Saran Singutlan, sir. And I also thank Sri Satyam College of Engineering and Technology for organizing this AICTE FDP 6-day program related to this semiconductor for smart systems, application in IoT, AI, and next generation devices. So I hope this is the last session. And let me start my today's session. So this is how to register a semiconductor IC layout design IP in India. So let me share my screen.
Yes, ma'am, please.
Sir, should I need to make my camera to be on?
Yes, ma'am. Yes, yes. Kindly you have to turn on your camera, please.
Okay.
Yes, madam.
So let me continue with this one. And good evening to all once again.
Good evening. Good evening,
Good evening to
madam.
all once again.
Good evening, madam.
So today let me start the session how to register a semiconductor IC layout design IP in India. So as this 6-day workshop is all related to semiconductor and most of the part are said to be from the technical part, and I think this session will be more different to you all people, and as this is related to of technical or legal aspect, legal aspect in and technical part is also involved in it. So let me start today. So I have moved to the second slide. I think everyone will be visible in this one, and this is the outline of my today's talk. So intellectual property, the need and the different type of IP. In short, I will be explaining all to you this, and then particularly let me focus on semiconductor integrator circuit layout design, and finally the how the semiconductor market is at present it is in the Indian scenario, and later we can go in depth with this semiconductor integrator circuit layout design Act 2000 and the procedure for registering this semiconductor IC. And then finally, let me give us some example of this one. So let me go with an introduction. So IP, intellectual property rights and its need. So you may be aware of these intellectual property rights. So nowadays people are more interested in having these terminology like intellectual property rights, patent, copyright, all these terms. So I think you may be having some knowledge in this one, and so let me give it the short introduction. So IPR, intellectual property rights, it is to the right to protect the intangible intellectual property. So you may be aware of the tangible as well as intangible property. So intangible is that the property which comes from our mind or it comes from our intellectual. So that needs to be protected. How we can protect it? It can be protected in different ways, and we can see in short or in brief we can do what these different types, and then we can go with this semiconductor IC. Okay. So similar to a tangible property, the property which comes from our intellectual, that is we call it as intangible, that need also to be protected and should be respected. So for this one, the intellectual property rights came, and it was framed by WIPO, World Intellectual Property Organization, and many countries is also following that. Around 198 countries is also following that, and India is also among the one. And what is the need for having these IP? So I can say that it provides economic and moral rights to the creator and innovators. So creator and innovator, generally we, the human being, may be the creator and the innovator, and in order to protect the economy of the country and to give a moral support to this creator and innovator, the rights came. Okay. So, and these rights were given to the public also in accessing those creation and innovation. Not only it is protecting the creator and innovator, but also it is giving right to the publics, those who are accessing those creations. So it is said to be a two-way protection for the creator as well as for the user who is using the creator's process. So we can say that it is giving right to in both the side, from creator side and also from the user side. And finally, we can say that it is promoting the creativity and innovation, resulting in the economic and social development of the country. So when both the users and the creators is getting benefited, and ultimately society will be also getting benefited. So the economy of the country is also getting developed, as well as the social development we can also see through the intellectual property rights. And also you people may be aware of the Global Innovation Index, GII. So right now India in this Global Innovation Index 2025, India is at the position of 38. So previously, before 4 or 5 years back, it is in the position of 80. Now we have reduced to 38. So which means that innovation is also developed in India, and the parameters also, we are focusing on those parameters or innovative parameters, how we can develop the country. So by this way, the economy of the country is also getting developed. So let me go in brief of the different types of IP. So as I said that the property which is coming from our mind or comes from our intellectual, that needs to be protected. That can be protected in different forms. So once the idea was arrives in the creative mind, that can be protected in 8 different forms. So I have given all these 8 different forms. I hope most of the people will be aware of maximum 4 or 5 IP in this one. So particularly patent, everyone will be aware of this one from the academic field. Patent, copyright is also the book what we are doing. It comes with the copyright. Patent, it is said to be an invention. So invention that should be new, should have inventive step and having industrial application. All these can be protected under patent IP. Copyright, the books, the way of expression can be protected with the help of these copyright example books or journal publication. Okay, this comes with the copyright. Trademark, for industrial people, this may be more familiar in order to identify the goods according to the quality of the goods and services. This trademark will be more useful. Like I can say that, for example, Amazon, people are aware of what this Amazon service will do. So this is identified by the recognition like this Bata or Amazon or Google. So this gives the trademark. And then the industrial design, similar to a patent, but it doesn't have inventive step, only for aesthetic appearance. That is only for eye appearance. If it seems to be novel, then that can be protected with industrial design. And geographical indication. So geographical indication depends upon the origin based, and when compared to the different type of IP, this is a special IP, and this IP is given only to the association of people, not to an individual. But rest of the IP, individual can also hold it. But geographical indication, only the association of people will hold it. The association of a people in a particular geographical location, if they feel that that product seems to be have a uniqueness with respect to that geographical area, then this IP can be protected. So for example, we can say that Tirunelveli Alva, or we can say that Tirupati Laddu. So all these are mentions that it is particular or uniqueness to that particular geographical location, and that is protected for with the help of this geographical indication IP. And then next is the semiconductor IC layout design. So most of the people are not aware of this IP. Let me give in brief or in detail in this session about the semiconductor IC layout design, how it can be protected and what it can be protected, and how it is important for this session, particularly with related to semiconductors. And so all this we in detail we can see it in the forthcoming slides. And then we can go, there is the other IP said to be a plant variety and former rights. So plant variety and former right is also said to be one type of an IP. And also in this IP, former rights is specifically only in Indian boundary. So in the rest of the world, they are having the production of plant variety alone. But in India, we are having production of plant variety. Along with that, we are having as former rights also. So we are involving the former also in this particular type of IP. And then trade secret is also there, though it is not so famous or familiar in the world, but still trade secrets is also there. But in India, it is underdeveloped, and recently we call it as undisclosed information. Not in particular of IP it exists in India, but still we are having it in the terms of undisclosed information. So there are 8 different types of IP. Once the idea comes in the creator mind, it can be protected in 8 different forms. And also I can say that all these are not new terms. So these are also exist in our olden days. For example, I can see you that you may be aware of the flag. Okay? Flag like Pandyan kingdom, you may be noticed that the 2 fishes will be in the Pandyan kingdom. Okay, so this is just and gives an identification of that particular kingdom. Similarly, in the recent days, we termed it as a trademark. So we can say that earlier also the same concept is there, but in a different terminology, and now we call this as an IP terminology with different types of IPs. So now I think let we all focus in this particular semiconductor IC layout design, as this session is more focused on this particular IP. So let me start with the introduction of the semiconductor IP. So they have given that the revolution in the field of information and technology and the replication of semiconductor chips. So the piracy is also there in the world. Okay, so by that way, the piracy of the chip piracy, it is also one of the major problem in the world. So due to that problem, this semiconductor integrated circuit layout design for topology arrives. The new IP has been arrived. So due to the chip piracy, this evaluation of this particular type of IP evolved. Okay, so you in bracket I have given it as a topography. So in the word we call it as a semiconductor integrated circuit layout design IP with topography. Topography, it is just a design, okay, not similar to a new novelty or inventive step as seen in the pattern. It is not available in this particular IP. So once this IP, before it evolves in the world, many people are confusing how this can be, this chip piracy can be protected or it can be avoided. Okay, so in order to avoid the chip piracy, act or a law should be, or legal terms should be there in order to protect this chip piracy process. So for that one, they thought to include this type of chip piracy to be to fall in any of the other category of IP. So actually this semiconductor IC recently it evolves, but people thought that how to introduce this, how to stop this chip piracy to be fall under, how to be protected in different IPs. So already the patent IP is there, already the copyright IP is there, but people are thinking that, how this can be involved with this existing IP. So, but when we compare with the patent IP, it requires novelty and inventive step. But as per the topography, it doesn't have any novelty or it doesn't have any inventive step. So this type of IP cannot, this type of semiconductor production cannot become under patent IP. So next they go with the copyright production. So when they think that whether this semiconductor IC can be protected under copyright IP, so that also a struggle comes. So as this doesn't have any artisan work, copyright protection mainly for artisan, which means that the way of expression, we are not expressing or we are not drafting any content or we are not drafting any booklet or a poem or drawings. So by this way, the semiconductor IC cannot also be protected under copyright. So next they go with the other type of IP like trade secret. So, but in the trade secret, you have to maintain the secrecy level. So, but in the semiconductor IC, once the chip was been designed and comes to the market by reverse engineering or chip piracy, it can be taken into multiple forms. Okay, so by that way secrecy level cannot be maintained. That's why it cannot be protected under trade secret also. So by this way, I think they thought that whether this can be protected under industrial design IP. That also a question rises. And as it is a topography, it cannot be filed with the patent IP. So they thought that as industrial design is said to be a form of protection for aesthetical design. For eye appearance, if it seems to be new, then that can be protected with the industrial design. So people thought that whether the semiconductor IC can also be protected under design IP, industrial design IP. But still there also a problem exists that a topography, though it doesn't have any inventive step, it has a design in it. But the semiconductor IC is said to be have an internal design. But industrial design is said to be a production for an external feature. So suppose, for example, if I am having a Coca-Cola bottle, the shape of the bottle, I'm not saying about the content which is present inside the bottle, but I am just saying about the external feature of the bottle shape, or it can be comes in a can also. So it can be comes in a 1 liter bottle or 2 liter bottle, or it can comes in the half liter bottle, or it comes in a can also, 100 ml to 100 ml. So all these have an external feature: the can, water bottle, the shape of the water bottle, the color of the water bottle, how it differs from the Coca-Cola and Miranda bottle. So all these, by identifying the shape itself, one can define that it is the product of Coca-Cola or it is the product of Miranda. So all this comes with the shape of the bottle. So it has an external feature. In that cases, industrial design production is okay. But when we go with the semiconductor integrated circuit, it is also a design, but it has certain internal design. It is not with external design. Whenever you see an IC at the top, you maybe notice that it is just a black portion in it, and it have the legs at the side portion, metal legs at the side portion. So this is only the external feature. By this external feature, how it can be differentiated? Either with a 8-pin, or it can be a 16-pin, or it can be a 64-pin, or it can be in the shape of rectangle, or it can be in the shape of square feature. So only this feature is different, but rest of the feature will be similar, and it cannot be able to differentiate between two different IPs. Okay, IPs. So that's why a special IP or a separate IP needs to be arrived in this IP field for protecting the semiconductor IC level. As the semiconductor IC is entirely having an internal design in it or internal feature in it, so that cannot be protected under design IP. So this is why the evaluation of this particular IP exists. So as I mentioned that in summary, I can mention that we have the patent IP, copyright, trademark IP, but trademark comes with, cannot be fall in this category. Design IP is there, trade secret is there. But in this category, how the production of semiconductor IC can fall in any of the category is a question mark in it. As I given this reason that as the patent doesn't have similar to a patent, the IC doesn't have any novelty or inventive feature, as it gives only the topography. It cannot also be protected under copyright, trade secret, or industrial design. So people in the world thought that how it can be protected. That concern like layout, topography of integrated circuits. Okay. And the Article 35 to 38 in the TRIPS agreement, it is framed by World Trade Organization. It's one part of the WIPO, World Intellectual Property Organization, the TRIPS agreement, the trade-related aspect of intellectual property, right? In the TRIPS agreement, they thought that to introduce a new IP that should have different features, and it should not fall on the existing IP like patent, copyright, trade secret, or industrial design. So in that category, they have introduced. So I hope my connection has been interrupted in this particular slide number, I guess. So let me start with this slide again. So in the TRIPS agreement framed by the World Trade Organization, in the article, particularly Article 35 to 38 in the TRIPS agreement is devoted only to the layout design of integrated circuits. And this article has been introduced in 1989, and it is particularly to give protection to the layout design. Layout design, it is the topography of the IC. Okay, so in order to avoid the chip piracy or the reverse engineering in manufacturing or in production the IC chip, this particular IP evolves. Okay, So layout design, topography, though it is considered with the layout design, but it also products the IC also, not only with the layout design, it also give production to the integrator circuit and also to a whole article. Whole article is the bigger version. So initial is the layout design, and after that it is combined to give a design. All these design will be combined to give an integrator circuit, and finally it gives a particular application in a particular article. So all these can also be protected in this same layout design of integrated circuit, though it means that it is not only giving protection only to the semiconductor layout design, but also it is giving protection to the IC chip also. With the result of that particular product also, it is giving protection. Okay, that article is also getting protected under this layout design topography of ICs. So next we can see that how India is also involved in having this production with chip piracy or in the reverse engineering. So that we can also see. Actually, India is being a signatory of World Trade Organization. So we are also in need to have this particular type of IP. So though the IP for this production of IP for this IC comes in 1989, but India have introduced this production of this IP only in 2000. So in 2000, India have framed a new IP like Semiconductor Integrated Circuit Layout Design Act, SICLDA, in 2000. So and also with the frame with the rules also, Semiconductor Integrated Circuit Layout Design Rules 2001. So Act came in 2000 and the rule came in 2001. This IP is particularly to give protection for semiconductor IC manufacturing companies, and as a World Trade Organization, they have introduced this IP in 1989, but India have introduced this IP only in 2000 and 2001. And let me go in detail with this SICLDA. So Semiconductor IC Layout Design Act, though the act has been framed in 2000, but it come to the public notification only in 2004. After framing the act and rule, then with the permission from the parliament, and then it come into existence and it come into notification to the public only in 2004. But later in 2011 only it is getting operated. Okay. Though the act is framed in 2000 and it comes to the notification to the public in the gazette, official gazette in 2004, but it came into an operation only in 2011. So see that though it is framed in 2000, but till 10 years it is still in the silent mode. Okay. So, but 2011 only it come into an operation. That is for 10 years, the act seems to be in silent mode. So it means that people are not aware of this IP protection. Okay. And next, but later we can see that in 2016 only, 2 layout design has been registered. Though the act came in operation in 2011, after 5 years only, the 2 layout design has been registered. Okay. And so far, only 2 design has been registered in India. So this may be a shocking news to you, but this is the truth. And so far, up to 2025, only 2 designs that has been registered in 2016. That is only the record which is available for the past 10 years. So from 2016 to 2025, for the past 10 years, only 2 design has been registered, and no design has been registered under the semiconductor IP. So this means that the awareness of this particular IP is not to the people. That's why when I talked to Dr. Kannan, I thought to introduce this particular type of IP one, and it will be more suitable to this session, so that at least people or faculty like you from the academic institution have an idea that this IP is still in India, and you may be aware that or you may be spreading this IP protection to the rest of the people also. That's why I thought to have this session in this technical part. And so for the past 10 years, only 2 layout design has been registered, and let me see all this more in brief with this session. In this session, so again, let me give an introduction part is not still completed from my side. And SICLD, the Semiconductor IC Layout Design Act, comes in 2000, but it is under the Ministry of Electronics and Information Technology. It comes with the MATI department. But now recently in 2022, this SICLD has been merged with Indian Patent Office. So Indian Patent Office, it comes under DPIIT Department, Ministry of Commerce and Industry. So from Ministry of MATI to Ministry of Commerce and Industry, it has been shifted. Okay. So before going into any of the IP, we need to have some awareness about its background. That's why I have mentioned which department now this type of IP has been given production. That is also a mandatory one to go before going into the production. So next we can see that what is the demand of the semiconductors in India. So India's semiconductor demand has been increased from 2022 for the forecasting. It mentions that 2030 up to 2030 the demand will be more. Okay, so from in 2020 it is said to be 1.1 and lakh crore. But now it is in 2025, it is said to be in 6.3, but it may be in after 5 years, it can be increased to 8.6. So we can see that how the demand of the semiconductor IP it is in India. So the need for production of this IP also, it is said to be more mandatory when compared to the other country, as India is also developing in the semiconductor field. So the production of this IP is also more important. So next we can see of the semiconductor chip. Semiconductor chip, as we be aware of that, it will be used in the computers, smartphone and other mobile communication devices, military system, car, aircraft. So all application nowadays is also using this IP. So the modern technology, everywhere we are using this IP. Everywhere we are using this IC. So in order to have these integrated circuits, we have to have a production in this particular IP also. So and also we can say that India recently is also become one of the competitor in the global semiconductor market. The concept of chip taker to chip maker, I think you may be aware of this chip taker to chip maker. So in the Make in India, they have given this, they have coined this terminology like chip taker to chip maker. So with that initiative recently, semiconductor industry market is also be evolved in India. So one in, yes, no, if I'm not wrong, it was in UP, they have going to build a semiconductor industry in UP, and even in Tamil Nadu also, the government is planning to build it in Coimbatore. Okay, so if this particular semiconductor market arises in India, then the production of this semiconductor IP seems to be a boom to India. By this way, we can say that Make in India or Digital India, we can have this one. Next, we can see what are the initiatives government have taken to have the semiconductor industry to be in India, to be framed in India. So the government have promised various degree of support to the companies who are setting or who are going to have a manufacturing of the semiconductor chip in different sizes. So the subsidy is as provided here, and this is from a government website. Particularly from the MATI website. I have taken this as from the source, MATI. So here, government is also providing subsidy in manufacturing the IC chip. So for the chip size less than 28 nanometer or from 45 to 65 nanometer also, the government is providing subsidy. Around 50% subsidy is provided if a chip, IC chip is manufacturing within less than 28 nanometer. So government subsidy is also there, which means that government has taken initiative in manufacturing this IP in Indian boundary. So far we have imported the IC, and even in the IIT Madras also, you may be noticed that recent IP, maybe 4 or 5 years back, we have noticed an IC or a particle, but they are also all the thing has been imported and only assembling in India has been performed. But nowadays we are focusing in manufacturing the same IP also. So in such case of manufacturing of IC production, then this particular IP will be also more important. So next we can see what are the government initiative project which there for particular to this Semiconductor IC Layout Act. So there is a pilot project of IT-enabled operation, maintenance and awareness of SIC LDR. SIC LDR, it is the Semiconductor IC Layout Design Registry, particularly for this IP. And it is implemented by CETA Delhi to create an awareness about this IC layout design. And this awareness program has been initiated in 2015 to 17 for 2 years. The fund has been provided in crores to create this type of IP, but still people are not aware of this particular IP. But though the people, general people are not aware of this one, but a large company is also aware of that one. That's why now they have initiated to start a semiconductor market in India. And also in the other side, the project like same specialized human resource development in IC layout design is also there. And this project has been given to the University of Pune for the period of three years from 2010 to 13 in order to create awareness about this IC layout design IP. Okay. So next we can see that definition of this particular. So now we can go in detail about the semiconductor IP. So we can see in detail about the semiconductor IP. Here I have given a definition. Here I have given a definition like semiconductor IC. So a semiconductor layout design means a layout of transistor and other circuitry element. It might be a passive element or active element, and also include the lead wire connecting such element and expressed in any manner in semiconductor integrator circuit. This is the definition which is given in the Act 2009. So it means that a layout of transistor, how the layout of this transistor, both active and passive elements, and the lead wire, how it is connecting, and how it is expressed in a semiconductor IC. That not only a design, IC is also included in Indian definition also. So design, how the layout of design of this, or how the layout of these active and passive elements, as well as the along with the interconnecting wire, and how it is expressed in the semiconductor IC is also to be protected. So all these is given in the definition. So this layout of transistor along with the interconnected wire in a semiconductor IC is said to be protected under the semiconductor layout design. So with an example also I can provide you this one. And this semiconductor IC is an integral part of every chip. You may be aware that IC is an integral part of every chip, semiconductor IC. Okay. And the layout of this transistor and other circuitry elements in a chip determines its shape and processing power. So processing power. So how the arrangement of this IC initially at the time of supercomputer, evaluation of supercomputer, you may be noticed that in the supercomputer, a room full of supercomputer has been now there. But now computer is said to be in the form of laptop also, or in the form of tablet. It is in our hand. So by this way, the size of the chip is also said to be reduced. The size of the chip is reduced, and the processing power is also said to be reduced. How this is occurring? All this occurs due to the layout of transistors. Okay, how you are focusing on, how you are laying out this transistor and the other elements in a semiconductor material, that will determine the size as well as the processing power. So in order to reduce that size and the processing power, you are going to design the layout, just a design where we can place this transistor in order to reduce the size, and where we can place these active or passive elements like counter or a flip-flop, how this can be placed in an integrator circuit. That can also be, or a resistor also we can go in detail, or at the basic level like resistor or inductor, how it can be placed in an integrator circuit. All these features in order to have the size reduction as well as to reduce the processing power. Okay. So in order to reduce the size and power, everyone is designing with the we come with the new IC in order to reduce the size. Okay, so how the layout of this transistor will be there. So the intellectual of the human mind is there, how to reduce the size and also not to compromise with the feature or the functionality of a particular IC. So in that cases, size is also important, power is also important, and the technical feature is also important. So all these keeping all this in mind, a new design has been evolved. So that needs to be protected under the Semiconductor IC Layout Design Act 2000. And the main feature is that what is the criteria in protecting this type of IC? It should be original, it should be distinctive, and it should be capable of distinguishing from any other layout design. So far, though it is two layout design, it is in India, but the search will be done all over the world. But though India have only two design, but the search will be done all over the world. So such designs should not be exist in the world, and in that cases, it can be protected, okay, under this IP. So the feature or the criteria by which design IC can be protected is that it should be original, it should be distinctive, capable of distinguishing from any other layout design, and it have not been commercially exploited anywhere in India or in the conventional country for more than 2 years. Suppose if I have manufactured this design and the IP, I have the IC with me, and if I introduce that in the market also, then still it can be protected. It can be protected, but it should be within 2 years. Okay, 2 years existence in the market can also be protected. The design which exists in the market within less than 2 years can also be said to be protected under this. Okay, and who can apply? Indian citizen or the citizen of 150 country can also apply. They can also apply it in their country, or they can also come to India and they can also apply it. Okay, so anyone can apply it, and here compulsory licensing may also be granted. Compulsory licensing, it is a special feature in the patent, particularly for pharmacy product it will be provided, but in semiconductor also compulsory licensing is also allowed. Though this act is not familiar to most of the people, that's why it is not there so far. But a compulsory licensing may also be granted, which means that suppose if I am having a IP manufacturing unit and I come with a new design IP, and that is also said to be protected under this IP. But as I have my own production and as I have my monopoly act in it, I am fixing the price of the particular IP. Suppose that price fixation is not favorable to the other people, then a compulsory licensing can be applied by a third party in order to have this design. As my product have a more, as I have a monopoly right, I am fixing the price with my own consent. So the price seems to be not affordable to the other companies. So in that cases, a compulsory license can also be applied by those competitors to me, and government will resolve this problem by providing compulsory license to the competitor also. So that is also possible. So compulsory license is that if anyone is asking for voluntary license also, if I'm owning that IP with me, in that cases it can also provide a voluntary license to the third people. But if my price is not in up to that affordable price, and I'm not also manufacturing that much quantity as per the requirement, in such cases, the other party or competitor can also apply for a voluntary license to me. And if I am not providing such voluntary license, then a compulsory license can be issued in the semiconductor layout design by the controller, okay, by the controller of patent office. They can also provide the compulsory license for the semiconductor IC if the price or the quantity doesn't fall within the criteria. So in all these cases, only IP has to be registered. If not registered, nothing will not be taken place. So next, we can see what is the procedure for registering the semiconductor IC layout design. So similar to the other IP, this procedure is also same. One or two difference is there, but still most of the procedure is same. If the idea is created, then it has to be executed. It has to be executed in the nanoscale level. Okay. So you have to design or you have to frame an IP or you have to make a design, okay, in a software module, then document it. Documentation, it can be provided in the drawing as well. Also, it have to be provided in GDS file, okay, graphic display system. So this GDS file 2 version is also needs to be submitted at the time of filing. So in the filing, we have to submit form LD1, form of layout design 1, along with that fees of 5,000 and plus this document like drawings, GDS, and its technical feature needs to be submitted along with form LD1 and fees, and it has to be submitted now. It needs to be submitted in the patent office. Earlier, it is with the MATE department, and now it is with the Ministry of Commerce and Industry department. So we need to file it in the Delhi Patent Office along with the form LD1, 5,000 rupees DD, and the documents of this GDS file. And this document is to be in a CD format. 3 sets will have to be submitted in that particular office. So 3 sets of form LD1 and 1 DD of the 5,000 rupees, and the 3 sets of document in hard copy as well as in CDs needs to be submitted in the patent office. It comes under the Ministry of Commerce and Industry. After filing, acknowledgement will be provided. Okay. So I hope my internet connection has been interrupted in this with this slide number. So let me start with this slide number, or should I need to go with this previous slide? So should I need to go with this slide or with the next slide, sir?
Ma'am, from next slide, ma'am, no problem.
Next slide.
Okay.
Next slide.
So with this, let me continue. And this production is for 10 years from the date of registration or from the date of the first commercial exploitation, whichever is earlier. Since even if it was comes to the market also, within 2 years we can have this registration. That's why the production of 10 years will be calculated from the date of registration or from the date of first commercial exploitation, whichever is earlier. The word is given in it. And section 54, it indicates the criminal penalties. So criminal penalties is nowhere exist in the other IP, but only the criminal penalty is there. But criminal penalty, the word, this terminology is nowhere in the rest of the IP, but only in the semiconductor IP. They have the term like criminal penalties. Rest of the IP, they have only the penalties. Only the penalty, it can be either with a fine, but now in the semiconductor IC, they have a word like criminal penalty as in the section 56. It means that imprisonment up to 3 years or a fine of rupees 50,000 up to a maximum of 10 lakhs or both can be also be implemented. Both fine as well as imprisonment of up to 3 years can also be involved if anyone is misusing the protected semiconductor IC layout. So that's why a criminal penalty is also here, and it is more particular only to this particular IP. And the criminal penalty can be up to a 3 years imprisonment is also there if a chip is said to be pirated or a reverse engineering is applied to the protected IC layout design. So next we can see the examples of the semiconductor IC layout design. So far as I mentioned that only 2 design has been registered in India. Though the act came in 2000, but still it is said to be in function from 2010 onwards. But from 2010 onwards, though it is in functional, but for the past 15 years, only 2 IC has been designed, registered. Okay. So 2 certificate has been issued so far. So first certificate is given to the ISRO for their design of 50 to 60 gigahertz sub-harmonic IQ mixers. Okay, so for designing the mixer chip, the design has been registered by ISRO in 2016, So in 2016, you can see that they have given this design of how the layout of these transistors. See, they have mentioned this to be a resistor and input output pad transistor. Here the transistor they are fixing it, and ground is provided with the wire. So this is one of the layer they give for production. And here it is the metal tracks. Okay, microstrip line it is given, and this layout design they have submitted for this design production. So they have given that this arrangement of this transistor and this resistor gives the functionality of the mixer compared to the existing IC in a better way of size reduction and in the processing power. So with this criteria, they have filed an application, and this design has been examined, and they have given the registration also. And this happens before 10 years back. So next is said to be a design which is the registration has been given and submitted by the Bell. So Bell company, they have submitted a design for an 8-port microcontroller IC. So this is the layout of the IC. So they have submitted the application in 2013, but after examination and every process, they got the certificate in 2015 January. Okay. So for around 1.5 years, their process was going on with the examination. Finally, they received the certificate in 2015, that too 10 years back. And after 10 years, no certificate has been registered so far in India. So this is said to be an 8-port microcontroller. You may be seen that the memory IC is also here, flash memory is also there, logic gates is also there. So as a whole arrangement of these all type of IC in a single, all type of passive and active element in a single IC, the design. So by this arrangement, how the size can be reduced, how the processing speed can be reduced, all these factors. So by this way, the design is also said to be registered. And now recently, India, from our council, the Tamil Nadu State Council for Science and Technology Pattern Information Center, we have an initiative of filing a new application under this semiconductor IC layout design. So this is the structure, and this is particularly said to be counter. Okay, so particularly for digital counter, for counter IC, application has been received from the Mohammed Sadak Engineering College, Kilakarai. So they come with the funded from the MAITI department. They got a fund for doing this project, and actually MAITI had announced a project. Around 100 project has been selected in India. They have provided the fund, and Mohammed Sadak Kilakarai College is one of them. And they got the fund, and now they come with the design, and they thought to product it under this IP. So we give suggestion to provide or to product this under the semiconductor IC layout design. They have come with a counter, digital counter, particularly for retinal disease reduction for medical purpose. They have manufactured, not manufactured, but they have designed a specific software program. And particularly, they have designed a counter, and that counter we thought to be produced under this semiconductor IC. So we have recently submitted in 2025 May, we have submitted this particular design under this semiconductor IC layout design, and now it is under process with the pattern of with the particular semiconductor registry. So this is the layout of their design, and they have designed this in though the size is said to be of 180 nanometer, but still we have filed application under this one with the GDS file of GDS 2 file and the 3 set of application. All these we have submitted in the office, and now we are waiting for the 3rd registration. So if they have given approval, then we are proud to say that Tamil Nadu will be one of the 3rd applicant in submitting this IP. So this may be a record in the history. And they have submitted the application to us under the category of classification. So by submitting the application in the LD form 1, there is a category classification. The column mentioned for a classification. The classification either can be for a structure or for the technique, or can be for a function. But this particular design, we filed it for a function. So with this, let me conclude over here, and if any query, I am ready to answer over here. And if in case you are having or a design with this one. So this is my last slide. So I thought to have an idea of even a council is also Tamil Nadu State Council for Science and Technology. In that PIC Pattern Information Center is also have taken an initiative in filing an application in supporting to the Mohammed Sadak Engineering College for designing an IC for a retinal disease detection system. They have designed an IC for counter, digital counter. And recently we have filed their application in May 2025. We have filed an application under the category of function category. So along with the GDS file, this category, they have submitted its application. And I request you participant, if you have any idea of registering this IP, then we are ready to help you on behalf of you. We will be filing an application on this one. So with this, let me conclude my session, and if any query, I am ready to answer over here.
Dear participants, if you have any queries and clarifications regarding the technical session 13, please clarify with our technical expert, Engineer N. Kumudha ma'am, please. So thank you, madam, for your informative and practically valuable session on intellectual property rights. Now, to propose the vote of thanks, may I invite Mr. V. Karthikeyan, Assistant Professor of Department of Mechanical Engineering. Sir.
Good evening, sir. Is I audible, sir?
Good evening. Yes, audible.
Yes, sir. Thank you very much, ma'am, for your deep full insights and informative session on how to register a semiconductor IC layout design IP in India. Your presentation provided a clear understanding of the need of intellectual property protection in semiconductor design and lucidly explained the Semiconductor Integrated Circuits Layout Design Act 2000 and its practical implications for the researchers, startups, and institutions in India. The participants found your explanation of the registration process under the SICLD Act and the eligibility criteria and the role of Patent Information Center highly useful, especially the way you simplified complex legal and procedural concepts into easily understandable steps. Your coverage of Indian government initiatives, including the CDAC awareness projects and examples of the registered designs from ISRO, BEL, and academic institutions added great value to the session. On behalf of the Department of Electronics and Communication Engineering, IQAC, and IAC of Sri Satyam College of Engineering and Technology, we extend our sincere thanks to you, ma'am, for accepting our invitation and for delivering such an engaging and practically relevant lecture as a part of our AICTE-sponsored ATAL FDP on semiconductors for smart systems, applications in IoT, AI, and next-gen devices. Your expert insights on intellectual property, creation, and production have indeed inspired our participants to consider innovation from both technical and legal perspective. We thank you once again, ma'am, for your time, your expertise, and your valuable contribution to the success of this FDP. Thank you so much, ma'am.
Thank you, sir, for your kind words and proposing vote of thanks so gracefully.
Thank you, sir.
Ma'am, thank you once again. You can leave. Dear participants, you will have the online test and feedback session at 6:30 p.m. sharply in the ATAL FTP login credential portal. Please, you can complete those two. First one is online test as well as the feedback session. Dear participants, you know the eligibility criteria to receive the certificates. The first one, if you want to take the online test, you must satisfy the attendance for the 6 days is minimum of 80%. If you want to take the certificate from the ATAL FDP, you should score minimum of 70% in the online test. I wish you all to complete your exam, that is online test successfully, sharply. It will start at 6:30 p.m. Then you will have the valedictory function at sharply 7:30 p.m. I invite all the participants to rejoin in the valedictory session sharply 7:30 p.m. Have a pleasant evening once again. It gives me immense pleasure to invite you all for the valedictory function of ATAL FDP organized by Sri Satyam College of Engineering and Technology on semiconductor devices for smart systems, in applications in IoT, AI and next generation devices. Let us begin this valedictory session with the Tamil Thai Valtu. I kindly request everyone to rise for the Tamil Thai Valtu.
நீராறும் கடலுடுத்த நிலமடந்தை கெழிலொழுகும் சீராறும் மதனமென திகழ்வரத கண்டமிதில் எக்கணமும் அதில் சிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை நுதலும் தரித்தனரும் திலகமுமே திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம்பியந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
Thank you. Please be seated. To formally welcome the gathering, I now take this opportunity to deliver the welcome address. Om Namah Shivaya, a very good evening to one and all. With immense pleasure and gratitude, I extend a warm welcome to each and every one of you to the valedictory function of the AICTE sponsored ATAL online 6-day faculty development program on semiconductors for smart system applications in IoT, AI and next generation devices, organized by the Department of ECE in association with IQSE and IIC at Sri Satyam College of Engineering and Technology. Over the past 6 days, this FDP has brought together a vibrant community of educators, researchers and professionals to explore the latest trends in semiconductor technologies, their integration with IoT and AI, and their pivotal role in shaping next generation smart systems. It has been a journey of learning, inspiration, and collaboration. We are deeply honored to have received the guidance and support of our respected chairman, Sir Dr. V. Balakrishnan, whose vision for academic excellence continues to propel our institution forward. We also extend our heartfelt gratitude to our beloved founder and principal, Dr. Sujata Ma'am, for her continuous encouragement, leadership, and unwavering support in organizing this FDP successfully. This week-long program has featured 13 technical sessions delivered by eminent experts from academia and industry, covering a wide range of semiconductor fundamentals and fabrication to AI hardware accelerators, cybersecurity in fab systems, and IP protections for IC layout designs. Each session has enriched our participants with new perspectives and practical insights into the future of semiconductor innovation. I would also like to acknowledge the dedicated efforts of our faculty coordinators, technical team, whose commitment and teamwork ensured the smooth execution of this FDP. A special note of appreciation goes to all of our participants for their active engagement, thoughtful interactions, and enthusiastic feedback throughout the sessions. As we gather here this evening to mark the successful completion of this program, let us celebrate not only the outcomes of these 6 days, but also the spirit of continuous learning and innovation that this FDP has inspired in all of us. Once again, I welcome you all to this valedictory function. Thank you for giving me this opportunity. May I now request our respected chairman, Sir Dr. V. Balakrishnan, chairman of Sri Satyam Group of Institution, to deliver the presidential address. We are privileged to have among us our respected founder and principal, ma'am, Dr. V. Sujata, to felicitate the gathering. Please, ma'am.
A very warm welcome and pleasant evening to one and all present here. Most respected and honorable Chairman, Dr. V. Balakrishnan, Sri Satyam Group of Institutions. Most respected resource persons of today's program, Engineer Gopi Gavaskar Pandian, Head Engineering Arc Global Inc., New Delhi. Engineer S.V. Sriraj, Director, Technical Operations, MCOG Solutions, Chennai. Engineer N. Kumuda, Project Scientist 2, Patent Information Center, Tamil Nadu State Council for Science and Technology, Chennai. Most respected Professor Dr. P. Kannan, Co-Coordinator, Head of the Department of ECE, Sri Satyam College of Engineering and Technology. Respected participants from various organizations all over India. Dear teaching and non-teaching staff members, heads of various departments of Sri Satyam College of Engineering and Technology. Good evening to one and all. With a deep sense of gratitude and pride, I present before you the felicitation address of this online 6 days ATAL FDP program. Over the past 6 days, our EC department, in association with IQAC and Institute Innovation Council, has been a hub of learning, collaborations, and innovations as we conducted a 6 days online ATAL FDP program on semiconductor technologies in smart systems with a focus on artificial intelligence, IoT, and future generation devices. And we have shared knowledge and exchanged our ideas and reflected deeply on the evolving role of semiconductor in shaping the future of academic and society. Today we gather to celebrate the valedictory function, the successful completion, and to reflect on the knowledge what we have gained and the path ahead. First and foremost, I would like to take this opportunity to extend my sincere thanks to the AICTE ATAL Academy for providing this wonderful platform for continuously empowers educators across the country. I would also like to take this opportunity to extend my special thanks to our chairman, sir, Dr. V. Balakrishnan, for providing all facilities, encouragement, and constant support that made this faculty development program a great success. My sincere thanks to all the expert speakers, resource persons from various academic institute, industries, who shared who shared their knowledges and insights beyond the classroom, and whose dedication and insightful session have made this faculty development program truly enriching. My special thanks once again to all the experts, resource persons. And I would also like to thank our co-coordinator, Dr. Professor Kannan, Head of the Department of ECE, for this faculty development program. Over the past 1 week, his dedication and hard work have shown in every detail. He did a great job by making clear documentations, providing clear instructions, coordinating the entire event with calm and efficiency. Sir, my special thanks to you for setting such a high standard and making this FTP a very useful and good experience. Thank you, sir. And my sincere appreciation may also extend to all the participants from various organizations for spending their valuable times each and every day from 6 p.m. to 9 p.m. to enrich their knowledges. My special thanks to each and every one, all the participants. And I would like to also extend my sincere gratitude and appreciation to all the heads of the department of Sri Satyam College of Engineering and Technology, teaching and non-teaching faculty members, those who have made their contributions in a very successful manner, and their meticulous planning and coordination provided a smooth and impactful program. Thank you, one and all. And coming to my point, dear participants, almost we have concluded today's all the 6 days program. Nowadays, the role of academician is far more dynamic and demanding than even before. We are not merely transmitter of knowledge, but we are mentors, innovators, and nation builders. So we are living in the era of changing technology. Each and every day, the technology is rapidly changing. So the classroom teaching is not at all sufficient to enrich our students. So we must update our skills and knowledge, and we must be a lifelong learner. We have to adopt modern technologies, and we have to use so many technologies in classrooms, and we have to make our students, we have to help our students to think in smart and create in a different way. So that is our major duty. Beyond teaching, our role, we have to concentrate more on research, innovation, and community engagement. We must coordinate to knowledge creation that address real world challenges and helps the build sustainable and inclusive growth. These are all our major role. We are the bridge between tradition and technology. We are the bridge between ideas and implementations. So this faculty development program was planned to connect classroom learning with real world application in semiconductor technology, especially in smart systems, artificial intelligence, IoT, etc. I hope this 6 days online FDP program would have provided so many additional knowledge to you, and it helped us upgrade your knowledge about semiconductor devices. We have learned more about how AI and machine learning can make systems and IoT network better and more efficiently. We understood the importance of next generation devices, and this FDP also aimed to bring together teachers and researchers from electrical, electronics, and computer science and related fields. So for the past 6 days, each and every day from 6 p.m. to 9 p.m., you all have spent your valuable time to enhance your knowledges. Each and every session, each and every day, we had two experts. We had two experts from various academic institute and industries. They have shared their knowledges, and around 200 participants have registered in this ATAL FDP program. Out of 200 participants, around 170 participants have shortlisted after successful completion of the preliminary exams. And today, you had also attended the online test. I hope everyone should get the digital certification after successful completion of your test. And you have to score 70% of minimum mark and 80% of the attendance. So all would have completed the entire test, and I wish you all the best. And before concluding my words, this FDP concludes, let us not see this as an end. We have to keep this is a new beginning, a chance to use what we have learned so far, and we have to bring the ideas to the classroom and keep growing as lifelong learner. Let us pledge to be an academician with purpose, educator who not only impact knowledge but also inspire transformations. Once again, I thank AICTE, ATAL Academy, all the experts, resource persons, coordinators, co-coordinators, teaching, non-teaching faculty members of Sri Satyam College of Engineering and Technology, management, and all the valuable participants who contributed to the success of this wonderful program. Once again, I thank you everyone. Thank you for giving me this wonderful opportunity. Thank you.
So thank you, ma'am, for your wonderful felicitation. May I now request our honorable and respected and beloved chairman, sir, Dr. V. Balakrishnan, Sri Satyam Group of Institution, to deliver the presidential address.
Good evening, sir.
Good evening, sir.
You are giving valuable and very honorable introduction to me. Very happy.
Thank you.
Good evening to everyone. I would like to extend my gratitude to all of you who participate in the 6-day ATAL online faculty development program on semiconductor for smart system application in IoT, AI, and next generation devices, sponsored by AICTE. I believe this program has provided valuable insight in the technology. My humble request to all of you is that merely participating or receiving certificate is not enough. You must apply what you have learned in this program in your respective field. So I congratulate all the faculty members of Sri Satyam College of Engineering and Technology, especially Dr. Kannan and the founder chairman, Dr. Sujata Madam, for their tireless effort in the successful completing of this program. So I am no way connected with this technical session, but I am very happy that so many participants are involved or participated in this program. I am so happy, sir. I also extend my special thanks to AICTE and its chairman for sponsoring this program. So we are planning to conduct so many programs like this online program. So I invite all the participants across the India to take participate in the future program also. Additionally, I appreciate all the participants from throughout India who took part in this program despite of their busy schedule. So I think this program may give you a valuable insight in your respective field. So thank you, Dr. Kannan sir. Thank you, Madam, Dr. Sujata Madam. Though you are a principal and you are the founder chairman of this institute, under your leadership, it may comes up in future in a very successful institution. Thank you, Doctor. Thank you. God bless you.
Thank you.
Thank you, sir.
So thank you, sir, for your presidential address. It is the time for the participants to share your feedback about this 6 days ATAL FDP organized by the Sri Satyam College of Engineering and Technology. I invite the participants, please share your feedback. Kindly unmute your audio and turn on your video. Please give your valuable feedback, please. Dear participants, kindly unmute your audio and turn on your video for giving your valuable feedback about this 6 days ATAL FDP, please.
Yes, good evening, sir.
Good evening, sir.
Yeah,
Good
yeah,
evening,
it's
sir.
audible, sir.
Yes,
Good,
audible,
good evening,
sir.
madam. Yeah, yeah. Really, actually, it's the ATAL online FDP was highly informative and well structured and provided deep insight into IoT, AI, and next generation device applications. The session was very were encouraging the faculty who's delivered the concept, even the complex concept, they delivered in the clear manner, enhancing understanding of the semiconductor technologies. Overall, it was valuable learning experience that will greatly benefit even my teaching and my research in smart systems. Thank you for giving the wonderful opportunity for joining us in this session, sir. In addition that, special thanks to Dr. P. Kannan, sir, also. Thank you, sir.
Thank you so much for your feedback, sir. Thank you. On behalf of Sri Satyam College of Engineering, I wholehearted thanks to you. Thank you.
Thank you, sir.
Thank you, sir.
May I know where are you from?
Yeah, myself, Rajendran from Amrita Vishwa Vidyapeetham, Narkol campus.
Okay.
Yes,
Okay. Thank you, sir. Thank you.
Thank
Thank
you,
you for your valuable inputs.
Good evening, all.
Good evening, sir.
Good evening, sir.
Myself, Dr. Bajaj Singh Solanki. I am from Purnima College of Engineering, Jaipur. I attended all the sessions related to this FDP. The session was very interesting and I gained a lot of knowledge from this session. And I assure you all, these sessions are very beneficial to all of you. As we know, the semiconducting material is a growing field in this era. So I congratulate all of you for conducting such type of FDP. Thank you all. Thank you very much.
Thank you, sir.
Thank you so much, sir.
Please, dear participants, kindly give your feedback, please. Ma'am, shall we move on to vote of thanks?
Okay, sir. Okay.
To propose the vote of thanks for this valedictory session, may I invite Dr. S. Mahendran, sir, Head of the Department of Electrical and Electronics Engineering. Please, sir.
Am I audible, sir?
Yes, sir.
Yes.
A very good evening to one and all. It is indeed a privilege and a pleasant duty to propose the vote of thanks on this memorable occasion, the valedictory function of the AICTE sponsored ATAL online 6-day faculty development program on semiconductors for smart systems applications in IoT, AI and next gen devices, organized by the Department of ECE in association with IQAC and IIC of Sri Satyam College of Engineering and Technology, Sangagiri, Salem District, Tamil Nadu. At the outset, I express our profound gratitude to the All India Council for Technical Education, that is AICTE, for sponsoring this FDP under the ATAL Academy initiative, which has enabled us to bring together experts, researchers and academicians from various parts of the country to share their expertise on emerging semiconductor technologies. Our heartfelt thanks to our respected Chairman Sir for his constant encouragement, visionary guidance and wholehearted support that made this program a resounding success. We are equally grateful to our beloved founder and principal madam for her continuous motivation, inspiring leadership and active involvement throughout the planning and execution of this FDP. A special words of appreciation to Dr. Kannan Sir, HOD ECE, Program Coordinator, for his exceptional leadership, dedication and tireless efforts in meticulously organizing this wonderful 6-day event with academic precision and excellence. I extend my sincere thanks to all our eminent resource persons who shared their valuable knowledge and experience on diverse themes such as semiconductor materials, device fabrication, AI hardware, cyber security in fab systems, IoT integration, and semiconductor IP registration. Their sessions have not only enriched participants' understanding, but also ignited new ideas for research and innovations. Our deep appreciation goes to the faculty coordinators, technical support team, and organizing committee members for their seamless coordination, and to our student volunteers for their enthusiastic assistance behind the scenes. To our participants from across India, we extend our warmest thanks for your active involvement, thoughtful discussions, and consistent participants in all sessions. Your enthusiasm and engagement were the true driving force behind this program's success. Finally, I thank everyone present here for gracing this valedictory function with your kind presence and blessings. Let us carry forward the spirit of learning, innovation, and collaboration that this FDB has fostered as we continue our journey in advancing semiconductor research and smart technology development. Thank you all once again. Wishing you continued success in your academic and professional pursuits. Thank you very much for the opportunity given to me. Thank you one and all.
So thank you so much for your graceful vote of thanks. Let us all rise for the national anthem.
जनगण अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तब शुभ नामे जागे तब शुभ आशीष मांगे गाहे तब जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे.
With this, we formally conclude the AICTE sponsored ATAL online FDP on semiconductors for smart systems, applications in IoT, AI and next generation devices. On behalf of the organizing committee, we extend our heartfelt gratitude to all our experts, management, principal, coordinators, technical team and participants for making this FDP a grand success. Wishing everyone continued success in research, innovation and teaching. I request the participants, you have to download your certificate from the ATAL FDP login portal itself. Once you complete your assessment examinations, one of the menu items in the participants portal, you have the certificate menu. So from that certificate, you can download it. Thank you all. Have a pleasant evening. Thank you, ma'am.